Yes,
Okay.
sir.
Sige, sige. For this afternoon, no? So same with 4B. Akong buhaton is akong i-present sa inyo ha ang no, during our kuan ba katong webinar no sa fire sprinkler system no the detailed hydraulic calculation. So I hope maminaw gid mo no. Ayaw ninyo pasagdi nga kuan lang recorded ra bitaw na siya kuan na no. Ayaw mo kaya na kay dako kay ning tabang sa inyo ha no actually. So this is kuan na gid siya. Real life na gid na siya nga application ha. Dili na siya ngon nga theory lang. So ma-apply na gid ninyo, maka-design na mo no once makasunod mo aning step by step nga hydraulic calculation din eh. Okay? So ang akong buhaton is next meeting na to mag-quiz ta ha, mag-quiz ta. Although mo hatag man ko recorded din yo copy pero after na sa quiz na to no para maminaw gid mo. Including tong PowerPoint presentation no apil na to quiz, okay? Then kato pong na-discuss na to sa PDF, apil po to siya. So starting automatic fire sprinkler system na discussion. Okay, I hope maminaw mo. So let me share my screen. Wala, maklaro ra ba ninyo? Plus? Hello?
Yes, sir. Klaro na.
Sige.
Akong binago sa kuwan ko sa
Okay, start na ta.
Okay, so let me proceed. Again, as shown during the first session, this kind of training na ino-offer sa inyo ng ATC, kung kukunin nyo ito sa NFPA mismo, it will cost you about 5,500. And to complete the whole NFPA 13, you need at least to shell out 16,500. I encourage you to try it para naman makita ninyo ang pagkakaiba. Pero ang touch lang kasi is that mas personalize ang offer ng PSME dahil Filipino ang instructor. Nung kinuha ko to noon, ay talagang speakers namin ay mga American. So talagang runny nose, kumbaga, dahil talagang pure English for the whole 2 weeks. It's a 2-week actually seminar, yung design. Kasi may dala kaming mga sarili naming laptop and to design. And another one, as shown last session, last Saturday, I am also again inviting you to try and attend this TMC2. These are all NPA speakers ang magkakandak nito coming from the US. If you are looking at the figures about the fees, complete naman kasi yan. Nandiyan yung module ninyo. Nandiyan yung handbook na yung NPA 72 or 13 or 14, nandun na yung handbook, kasama na yan dyan. Aside from the certificate from NPA mismo. Gagawin yan sa Eastwood, sa Libis, sa Richmond Hotel. So, pinapakita ko to sa inyo para at least ma-appreciate ninyo na not only the Singapore and Hong Kong and Malaysia are doing this. So sa Pilipinas, at least mayroon ng isang naglakas loob na mag-invest sa ganito. Mga kaibigan natin sila, they are owned, TMC2 are owned by fellow mechanical engineers. Okay. Again, before I proceed, I would like to remind you, kagaya nung ginawa natin, and every time na may pa-seminars at ako speaker, is to remind everyone about our civil liability under Republic Act 386. So napaka luma pa to, hindi pa to na-update. It's a 1949 Civil Code of the Philippines. So walang pagbabago, 1949. Imagine that hanggang ngayon. So ulitin ko, hindi ako magsasawang sabihin to. At para ma-remind kayo, since you are all engineers or architects, the engineer or architect who drew up the plans and specifications for a building is liable for damages if within 15 years from the completion of the structure, the same should collapse by reason of the defect in those plans and specifications or due to the defects in the ground. Pwede nating i-excuse ang mechanical engineers, maybe the electrical, pagdating sa defects in the grounds, kasi more on civil and architecture yan. However, kung kayo ang magdi-design ng pump or pumping or pump foundation, nasa inyo yan, ground yun, pinakailaman nyo na kayo ang magdi-design ng fire water tank, those are ground. So, liable na rin ngayon doon. So, liable tayo, what I mean. 15 years, guys. 15 years. So, and the contractor, yun, mga designer yun. Yun na una, the architect, engineers, design, plans, di ba? Specifications. Ito naman si contractor. The second paragraph is likewise responsible for the damages if the edifice falls. Edifice panggamit, 1949 kasi, within the same period, within 15 years, on account of defects in the construction or the use of materials of inferior quality furnished by him or due to any violations of the terms of the contract. So, inferior quality. Ito naman is about contractors who uses inferior quality. And the third paragraph, ito naman yung mga sa supervisors. Excuse me. If the engineer or architect supervises the construction, he shall be solidarily liable with the contractor. O, di ba? So, ang klase example dito is not the contractor, hindi lang yung engineer ni contractor, pati na yung nag-accept, yung owner's engineer. And the fourth one is, ito mabigat, yung testing and commissioning daw, yung certificate of completion does not imply waiver. Acceptance of the building after completion does not imply waiver excuse me, of any of the cause of action by reason of any defect mentioned in the preceding paragraph. Now, last time may pinakita ko sa inyong cases, a classic case. Ang excuse lang ng engineer dito actually is the force majeure, acts of God, and the acts of third party. However, yung acts of God naman, lindol, baha, bagyo. Mayroon namang parameters pa rin sa design. Sa lindol, 7.5. Bagyo, 250 kph. Dapat ang design mo mag-sustain sa ganun. May mga parameters pa rin. So talagang hindi talaga siya, yung acts of God ay walang, ang iba doon, controllable pa rin yung lumalabas na iba doon kasi you can foresee that. So mayroon mga provisions. Pero, of course, you can excuse, you can be free kapag napatunayang it is force majeure or acts of God. Another one is you can be free from liability if it is acts committed by a third person. Pinasabog, di ba? Sinunog, sinabotahe, mga ganun, third person. So, pero kung sinabing designer, kinontrata mo yung designer, in-outsource yung designer, hindi yung third person, hindi ganun. So, ang third person dyan ay talaga yung intentional na talaga sisirain, yung sinabi ko sa inyo. Okay. Now, let's review. Before we proceed with the hydraulic calculations, let us review first our learnings. Okay, 13 gives us 3 design approaches to choose from. Okay, the design of automatic fire sprinkler system. 1 is occupancy hazard fire control approach. 2 is the storage design approach. And 3 is the special occupancy approaches of Chapter 22. So lahat yung Chapter 11, 12 to 20, at saka 22 are all NFA 13. Now, ang pag-uusapan natin dito ay ang number 1 approach. Nandito yan. However, lahat yan, 2, 3, those are all hydraulic calculations. Ang pipe schedule dyan, iisang section lang eh. Now, okay. Again, storage design houses Sabi ko, are the design for those occupancies, storage and warehouses are different, is a different animal. Kasi karamihan dyan, plastic, papel, di ba? Mga cartoons, those are extra hazards. May mga flammable materials pa, and liquids. Okay. When we talk about occupancy hazard fire control approach, we are given with two choices. Either we go on pipe schedule or hydraulic calculation. At kapag hydraulic calculation, ito pag-uusapan natin ito, binibigyan tayo ng tatlo. Either density area method, the room design method, and the special design area method. So lahat ng methods na yan ay hydraulic calculation yan. And for this presentation, density area method ang gagamitin natin. Density area, because that's the most common and the most used design method pagdating sa hydraulic calculation. So we will be going to use density area method. Okay. Let's review again. Flow. So I hope you remember these equations. The first equation is Q equals AV, where and Q or for the sprinkler, the basic of the empirical equation is Q equals AB, and the flow from sprinkler is given by the formula density times the sprinkler coverage area. Then nag-walk around tayo, nagkaroon tayo ng walk through sa formula, and we were able to derive the following formula for Q, another formula for Q, which is the K factor times the square root of P. Now, I will be using English system, PSI, flow, GPM, and the K factor of GPM over the square root of PSI. So, kasi doon ako sanay. Pasensya na sa mga millennials, pero kung kasi ako tao dito, old school pa. So that's why pagbigyan nyo na ako. Alright. So when you derive the formula for P and K out of Q equals K squared to P, then you have it in your screen. P is Q over K squared and K is Q over the square root of P. Loss is PSI per foot. Pag yung PL, minultiply mo na ng total length of pipe, then you will have your friction loss in PSI. Okay, roughness coefficient. So, table 22447 of NFPA 13, binibigay dyan sa harapan nyo ngayon ang mga C value or your roughness coefficient. So, what we are using is natin na ginagamit ngayon, which is CPBC. Yung CPBC, yan kasi ang chlorofluorovinyl chloride, those are the kind of plastic materials that is allowed to be used for fire protection, but intended only for light hazard. Do not use CPBC for ordinary and extra hazard kasi light hazard lang siya allowed. So, ang gamit niya ay 150. So, lumalaki ang numbers, pag lumalaki ang numbers, mas nagiging smooth laminar flow. Wala siya masyadong turbulence. Now, this roughness coefficient is one of the safety factors built into the Hazen-Williams calculations. The typical C factor value for new pipe is 140 and 150. But NFPA 13 recognizes that the pipe will corrode over time due to its contact with water or air and anything that's carried by the water into the system. Therefore, the C factors of 100 or 120, depending on the type of systems, are used. The lower the C factors, the rougher the materials. Now, this is the reason why in the hydraulic calculations hindi naglalagay ng safety factor. Wala nang safety factor na pagkatapos mo ng pag-calculate dahil mismo the formula itself na ginagamit ay mayroon ng safety factors. na nakapasok na mismo sa mga empirical formula. Oh, Hayes-Williams C values is being used in the value of C here in your formula. At nandiyan yung safety factor. So, di ba? Ang sinasabi dito, when a new black iron pipe or B pipes are fabricated, 140 to 120. Pero sinasabi ng Hayes-Williams, no, 120 lang yan because of corrosion. So, na-forecast niya yung corrosion. And another one are fittings. So, energy losses through fittings are caused by turbulence in the water. So we were given last time about the equivalent length of pipe. So, sana natandaan nyo. Anyway, I will be showing you again. And the PA13 has a table provided for that equivalent pipe lengths. And the table of the fittings or of the equivalent pipe length of fittings is based on Schedule 40 wet pipe system with C values of 120. Kung gagamit kayo ng Schedule 30, Schedule 80, iba ng schedule, now, this equivalent length na table ay hindi na uobra. So you have to account for adjustment. So mamaya may mga adjustment naman yan. So tandaan natin, ang equivalent length na table na provide niya ni PA13 ay nakabase lang sa Schedule 40 steel wet pipe system with C values of 120. Other than C120, other than Schedule 40, you have to compute for equivalent. Now, so all fittings must be accounted for, like the teeth, the elbows, and including the bulbs. Some pressure loss, however, can be taken from the manufacturer's listing information. At kapag binigay yan ng manufacturer, use that information. Use that friction loss kasi okay na yan. Now, there is a special provision not included in the friction loss calculation. So, all fittings directly connected to sprinklers. Halimbawa, gumamit ka na ng elbow reducer, 1 inch to 1/2 na elbow reducer. Sa 1/2 na dyan yung sprinkler head mo, hindi mo na kailangan pang i-calculate yung friction loss because of that elbow reducer. Kasi nakakabit na mismo sa elbow or even your T-reducer. Nakakabit na mismo yung sprinkler doon. So, hindi mo na kailangan i-calculate. Another one is if you are using straight coupling without changing direction, yung mga bakal, di mo na kailangan pang computin yun ulit, yung friction loss based on that. However, kapag ang ginamit mo ay CPBC, ay kailangan mong i-compute yung straight coupling ng CPBC. Bakit? Sabi ko nga dati, before, because of the cement or chemical na ginagamit mo to fuse the CPBC. Dahil nagkakaroon siya ng deposition. Okay. Ito yung equivalent line chart na nakabase sa Schedule 45 Z factor roughness coefficient of C of 120. Ayan yan. Okay. So, kung makikita mo mayroon dating standard elbow, tandaan yan. Mamaya ma-encounter natin yan. At saka ang long turn elbow. Okay. Standard elbow and long term. Makikita natin yan. So there are two different kinds of that. Now, let's review again. Let's take for example your 1 inch. If you have a 1 inch T, T equal or T standard, mayroon kang 1 inch T equal. Kapag dumaan dyan ang tubig, nawawalan ka ng 5 feet. Nawawalan ka, hindi inches, hindi ka nawalan ng 5 inches, kundi feet. If you have 1 inch T equal or T standard. So, nawawalan ka ng 5. Now, sabi rin ng NFPA 13, sa check valve, itong presentation sa check valve na to, lahat yan ay average. Kung bibili ka ng check valve, kunin mo yung manufacturer's data. Ano ang friction loss ng check valve nila? Pag wag lang binigay sa manufacturer's data, sa materials document, itong gamitin nyo. Itong sa check valve, ito yung average na to ng check valve. Okay. Pero tingnan nyo, pag gumagamit ng check valve, look at that. Gumamit ka lang, karamihan kasi is 4 inch ang riser, ang discharge at saka 6 inch karamihan. Pero tulad mo sa 4 inch, nawalan ka agad ng 22 feet. Kung dumaan ang tubig dyan sa'yo, sa 4-inch na check valve na yan, nawalan ka na agad ng 22 feet. Okay. Sprinkler K-factor. The discharge coefficient refers to the amount of water that is permitted through the sprinkler. Oh, ito yung mga K-factor na sprinklers. Part na sprinklers, this is a pendant type. One is deflector, ito yon. Then the frame, the glass bulb, that's the seal, they call that plug, and the thread. So, yung kung 1/2 ito, inside diameter ang 1/2, yan ang 1/2. Wag na wag niyong sukatin ang caliper dito sa labas. Kasi malilito kayo dyan, hindi yan 1/2. Almost 3/4 na yan. So baka bumili kayo ng 3/4 na pipe. So 1-inch pipe, tapos magkakaroon kayo ng reducer. Either concentric reducer, elbow reducer, or T-reducer, 1/2. Okay. So the baseline is always 5.6. Ito yan, 5.6. 5.6. Kaya makikita mo, nakabase siya sa 100% flow discharge. Habang lumalaki ang K-factor, nagiging lumalaki rin ang discharge niya. Lumalaki. Now, what is the biggest now? It's 25.2. Pero yung alam ko, yung Viking gumawa na ng 28. Another. Okay. This is from I took this from Mayer Fire. So makikita nyo dyan, for example, the sprinkler coverage area for standard spray is commonly at 130. So ibig sabihin nito, 130 square foot, yan ang coverage area ng isang sprinkler. Ang density, halimbawa, ang density niya ay 0.15, then the flow is 19.5. Remember, paano mo yan kinukuha? Dito yan, no? Q is equals to K, the square root of P. So, you have your K factor. Halimbawa, ito yung K factor mo. 8. Halimbawa, ito yung 8. Ipapasok mo yun sa K. Then, you have now the flow. You have now the flow of 19.5. Makukuha mo yung pressure. Now, I want you to check this 7 PSI. Look at this. Dito, muna sa baba, sa taas, kapag 5.6 ka, according to code, according to NEPA 13, the minimum pressure na dapat lumabas sa sprinkler na yan ay 7 PSI. Now, to meet the density na 5.6, kailangan mo ng 12.1. Actually, actual flow mo niyan ay 19.5 GPM. At ang pressure mo niyan ay 12.1 PSI. Pero ika-calculate mo lang siya ng 7. Maski pa siya tumaas. Kapag naman lumaki bumagsak ang pressure, pababa ng pababa, ang gagamitin mo pa rin 7. Lagi 7. Para, ano ang effect nito? Lalaki ang pump pressure rating mo. Para ma-meet mo itong 7 PSI. Okay, so this is our density area curve. So I hope you still remember this. This is your density. For example, in your ordinary hazard, usually, dito tayo di ba? Ito. Sabi ko sa iyo, this is the most economical. This is your area of sprinkler operation, 1,500 to 2,000 or 2,000. Yan ang gagamitin nyo. Ano yan? Yan yung remote area nyo. Sa 10 floor, sa pinakamalayo, maski pa yan 500 or 1,000 square meter isang floor. Kukuha lang kayo ng 1,500 to 2,000 square foot. Kapag ginamit nyo yung 1,500, ang density mo ay 0.15. Of course, kapag ginamit mo ang 2,000, ang density mo ay 0.14. Ito yan. 0.14. Di ba? Now, may kanyan. Kapag nagkaroon ka ng mga adjustment sa area na to, reduction and increase, dapat pumatok ka sa 3,000 lang maximum. Kapag ordinary hazard. 3,000 kapag may mga concealed spaces ka. Okay. Extra hazard group 1 and group 2, nagsisimula siya sa 2,500. 2,500. So hindi ka pwede gumamit ng 1,500 at saka 2,000 kapag pinag-uusapan na natin extra hazard. Bakit ganon? Nilakihan ni NFPA yung design area mo. Sa 10th floor, instead of 1,500 square foot, ang hahanapin mong minimum ay 2,500. Bakit? Extra hazard na kasi. Extra hazard na. Next, sprinkler heads. So, 6 main characteristics that define a sprinkler's ability to control or extinguish a fire is the thermal sensitivity, temperature rating, the orifice size, installation orientation, water distribution, and special service conditions. I would like you to introduce to the different kinds of sprinklers. What that we call, first is the standard response or SR. So, mag-i-specify na kayo ng sprinkler. So, pwede nyo isabihin, standard response pendant or standard response upright. Ano yan? These standard response sprinkler heads work by wetting and cooling the area surrounding a fire to prevent it from spreading. Once the fire consumes all the fuel around, it goes out. Pag na-consume lahat ng fuel, paano kung hindi? So, ang purpose niya is to prevent from spreading. Mapuput off lang ang fire kapag naubos na ang fuel. Remember the fire triangle? Di ba? The heat, the oxygen, and the fuel. Pag binigyan mo siya ng chain reaction, fire will come. Pero alisin mo ang isa sa triangle na yon, wala kang fire. O, naubos na ang fuel, saka lang siya mawawala ang fire. Now, this approach aims to suppress the fire source to slow down the spread of flames. So, drenching the surrounding area slows the fire, buying critical time for fire department to get on scene. Okay. Usually, yan ay 5 mm glass bulb. Ang diameter niya ay 5 mm. Now, quick response. Okay. Pag quick response, yung bulb niya ngayon ay lumiit. Naging 3 mm. Para naman quickly, mabilis siyang mag-boil, mabilis siyang bibigay. That's why quick response na siya. Pero walang pinagkaiba yung dalawang yan. Standard response and quick response as to materials and sizes. Nagkaiba lang yan sa bulb. Niliitan lang yung bulb. Naging 3 mm bulb lang. They have similar fire control as standard response but the mission is slightly different. A QR sprinkler discharges water higher on the walls to keep the fire from climbing and maintain lower ceiling temperatures. Cooler ceilings reduce the likelihood of flashover. QR sprinkler head's mission is to improve the odds of human survivability. Mabilis siyang mag-response So it improves human survivability. They are used to primarily in light hazard applications like highly populated buildings such as healthcare facilities, assisted living facilities, office buildings, or schools. O yan. QR sprinklers as 3 mm. So hindi mo pwedeng gamitin ang QR sa warehouse. So ito yung sample. So yung pag-train ng mga sprinkler set mo, ito SSP standard spray. Pendant. Pendant yan. U upright. Ito yung model niya. So ito yung listing niya. UL, FM, LPC, loss prevention and LPCB control board. Okay, so walang B siya. Quick response, 68 degrees C, yan ang opening niya. Okay. Is equal to 155. 68 degree is equal to 155. So ganun yan. Now, I would like to introduce you to extended coverage. Extended coverage provides extended area of coverage compared to standard coverage spray. Ito yan, the example, this drawing. Instead of 1, 2, 3, 4, 5, 6, gagamitan mo lang siya ng extended coverage, almost makover na lahat. Dalawa lang na extended coverage. So, mahal nga lang to. Pero sabi niya, ay gamitan ko, kung ganyan lang naman pala, at napapalaki lang naman ng area, ang coverage, idagdagan ko na lang ng pressure. Tama nga naman. Pag dinagdagan mo ng pressure, magiging mist siya. Pag naging mist na siya, yung water mist na, ay di lalaki ang coverage area. Pero hindi ganoon eh. 'Di ba? The object is to drench the fuel to put up the fire. Pag mist, nasaan siya? 'Di ba? Dadali lang siya ng oxygen. Mist na kasi. So this is not the reason. That is not a good reason para magkaroon ka ng extended. Dagdagan mo ng pressure yung conventional sprinklers mo, yung standard spray. Next is ASFR. Ito yung mga pang-warehouse. Early suppression, fast response. So this is ceiling mounted. Ibig sabihin ng ceiling mounted, nilalagay sa ceiling. Kaya, then, usually for storage and warehouses. In place, in lieu of in rack. O ayaw mo maglagay. Why? Ayaw mo maglagay ng rack. Kasi baka magiba. Kapag lumindol, pwede magiba, mag-collapse ang racking system mo. So, wala na ikaw ng sprinkler kasi nasa racks ka. So, ilalagay mo ngayon sa bubong, ceiling mounted. So, nakakabit, malapit sa bubong. So, it incorporates very large, high volume, high pressure heads to provide the necessary protection without the need for in-rack sprinklers. So, usually ginagamit yan sa mga palletized, solid pile, shelf, bin box, or rack storage materials. Now, by the word suppression, it is a suppression mode. Hindi ito control mode. So, ang design nito is that really to suppress the fire para kasi extra hazard eh. Baka kapag control mode lang yan, ma-overpower ng apoy, ng fire yung sprinklers, pag na-overpower, mauubos yung warehouse mo. And kapag delikadong kumalat because of the flammability of content. O, di ba? Okay. Now, we were also introduced last session about the adjusting of equivalent lengths. So, sabi ko nga, yung NFPA table for equivalent length of pipe is only based on Schedule 40 pipe for wet systems. All others need to be adjusted every time there's a change in pipe material. C factor other than 120, you have to adjust the length. The change in interior diameter other than those for Schedule 40. For example, gumamit ka ng Schedule 30, iba ang inside diameter nun. So you have to adjust for the equivalent lengths. And for using other factors, halimbawa, di ba ang gamit natin 120 lagi? Ay, paano kung gumamit ka ng 100? Di may multiplying factor kang 0.713. Gumamit ka ng 150, you have a multiplying factor of 1.51 for you to be able to arrive to an equivalent C120 roughness coefficient. Inside the diameter, you use another pipe. So, gamitin mo lang yung actual inside diameter ng pipe na ginamit mo na hindi Schedule 40. The actual inside diameter of a pipe like na Schedule 30, Schedule 80, over the Schedule 40 is inside pipe diameter. Raised to the power 4.86, then you will have your adjustment for inside diameter. Design area. Kapag ang gamit mo ay dry pipe system, you have to increase your design area. Yung 1,500 mo, yung 2,500 square foot, lalakihan mo ng 30%. Dry pipe. Bakit naman? Kasi kung high-rise building yan, tapos dry pipe, di matagal yan. Matagal makarating ang tubig doon kasi ang tubig nandun lang sa bunganga ng pump. Nandun lang sa pump area. Okay. Saan mo ginagamit ang mga dry pipe system? Storage, di ba? Or sa wet or sa mga countries na nagyayelo. Sa Pilipinas, wala naman tayong winter. So, ginagamit ang dry pipe systems sa cold storage facilities. Now, double interlock pre-action, you have to increase your 30% again. Bakit? Bakit double interlock pre-action? Diba pre-action systems, as you may have learned, as you learn from your basic fire protection engineering, is that may single interlock and double interlock. Gagana muna dapat si smoke detector, gagana muna dapat may apoy muna para ma-melt ang sprinkler head, so double interlock siya bago pumasok ang tubig. Kaya yung mga double interlock pre-action systems na yan ay either may gamit na nitrogen or compressor. Then, extra hazard occupancy using high temperature. If you are using high temperature, you can decrease your design area by 25%. But minimum of 2,000. So, hindi na pwede bumaba hindi na pwede gumamit pa, nag-decrease ka na ng area, baka umabot ka ng 1,500, hindi pwede. Na. Another adjustment, quick response. If you are using a quick response sprinklers, then your area of operations can be reduced from 25 to 40%. QR sprinklers. Bakit naman? Kasi quick response yan eh. So kung mo quick response, madali siyang bumigay, so yung design area mo, makukover ka agad. So you are allowed by the code to reduce from 25 to 40%. When When it is wet pipe systems only, light or ordinary hazards lang. So hindi pa pwede gamitin ang quick response sa extra hazard. Warehouse, for example, is an extra hazard, hindi pwede ang quick response. 20 feet maximum ceiling height. More than 20 feet, hindi na. No unprotected ceiling packets and no less than 5 sprinklers in the design area. There's no change in the design density, only the area. And area may be less than 1,500. Pwede na. Diba? In your area density curve, ang pinakamaliit niya ay 1,500. But since you are using a quick response sprinkler head, your design area may be less than 1,500. Next, this table shows how to apply the quick response design area adjustment. Okay, let us navigate. For the ceiling height of less than 10%, less than 10, this is your ceiling height, less than 10. Your reduction is maximum 40%. If the ceiling height is 20 feet, reduction is 25%. If the ceiling height is between 10 to 20 feet, the reduction is given by the formula. This reduction is given by the formula. Y is negative 3x over 2 plus 55. Over 20 feet ceiling height, no reduction is allowed in the design area. Bakit allowed ka magkaroon ng reduction? Because it is a quick response. Design area adjustment again, if you have a slope ceiling with an angle of 9.46 or a rise in run of 2 and 12, then you have to increase your area of operation or your design area by 30%. Kasi bakit? Di ba kapag nasa roof deck ka, sumusunod ngayon sa contour ng iyong roof deck, ng iyong bubong ang branch line. Magkakaroon lang yun ng hindi susunod. Ipapantay, magiging perpendicular ka lang. Perpendicular sa iyong roof deck, sa iyong trusses. Kung ang daming obstruction dito, grabing obstruction naman, na kapag naglagay ka ng ganyan ng sprinkler dyan, halos wala nang bumagsak. Or napakataas ng todo-todo, ang grabe. Tapos ang liit. Okay. Now, let's go to the hydraulic calculation principles. Dali lang, mukhang nagkuha ng laptop ko. Lowbat. Wait lang guys, mukhang naglobat ang laptop ko. Where's me? Okay. Moment. Okay. The design layout process or the hydraulic calculation process. First is you have to define first the hazard. Malapit na magka-calculate na tayo, magdi-design ka na. Kasi after this, ang tanong nyo sa akin, Alex, pagkatapos ba ng seminar na to, pwede na ako mag-design? Yes, pwede na. That's why you are here. Ibibigay ko na sa inyo ang lahat na kailangan nyo. So, before you calculate, you have to define the hazard. Is it light hazard, ordinary hazard, extra hazard? Okay. Next is analyze the structure. Tingnan mo, ano bang structure na to? Ano ba ang laman? Ano ba yung mga semento, bakal? Kung ano yung pagkagawa ng building? The structure, floor, plans, elevation. Analyze the water supply. Am I going to get it from the pond, from the river? O mayroon silang deep well? O meron silang supply from Manila Water, from concessionaire. And select the type of system. Or am I going to use wet pipe, pre-action system, dry system? Then sprinkler types and locate them. So now, kapag locate them, ang ibig sabihin niya, magdo-drawing ka na. Take your plan, ilagay mo na ngayon ang sprinklers mo, doon sa module 1 pinakita natin doon kung ano, saan mo siya ilalagay. Di ba? Usually, ang ginagawa yan is 3 meters. Bakit 3 meters? Kasi para hindi masayang sa pipe. Your pipe is 6 meters. Yung karamihan na pipe na branch na by standard length, hinahati yun ng mga contractors because that's the what you call the most economical. Hatiin yun. So, kaya nilalagay ngayon every 3 meters na. Pero hindi. You're allowed up to 4.6, di ba? Branch line, sprinkler head to sprinkler head branch line. Yun nga lang, pag nilagyan mo na siya ng mga circles, to get your 130 square foot area, kapag area na, siyempre lagyan mo siya ng circles, baka hindi na mag-overlap. Then, you arrange the piping. Drawing na talaga dyan. Then, locate your hangers and bracing, and system attachment, the valves, yung mga ganon. Saka ka na mag-hydraulic calculations. Hindi ka pwede dumanit sa hydraulic calculation na wala ka pang drawing. Because you need those drawings. Kasi doon. Okay. Ito yung mga iba't ibang klase ng hazards. Hinati ko siya sa combustibility of content, amount of combustibles, heat liberation, and the amount of flammable or combustible liquids. So light, ordinary, and ordinary hazard has no flammable or combustible liquid, while extra hazard group 1, little or zero amount, while extra hazard group 2 has substantial amount. So you can take a picture in that. Sinamarize ko na yung mga ng hazards. Okay. Ano pa ba bang pwede ko sabihin dito sa inyo? Okay, ito. Tingnan nyo to. Ordinary hazard group 2. Amount of combustibles is moderate to high with stockpiles. Don't exceed 12 feet. So, ano kaya to? Kung may stockpiles ka na, ito na yung maaring warehouse. Simula ng warehouse na to. Simula na ito ng mga department store, shopping supermarket kasi may mga stockpile sila. So, dapat ordinary hazard group 2 yung mga yung mga pinupunta nating supermarket. Kasi may mga stockpiles yun that do not exceed 12 feet. Okay. Hydraulic calculations or hydraulics are affected by the type of sprinklers. Because this kind of sprinklers has different pressures, starting pressures, different coverage. Ibig sabihin, ang standard spray, halimbawa 130 square foot, ito extended coverage, malaki, na 425. Ang in-rack naman, maliliit ang coverage. And they have different K factors. And also, the hydraulics are affected by different kinds of calculation methods. And of course, another consideration for the hydraulics is your piping configurations. 3, the loop, the gridded. So those, and the pipe size and Matias, and the 5 fittings, all of these affect your hydraulics. Okay, the 3 systems. So we are still on the review for those who just came in. We are just reviewing first habang naghihintay kami sa inyo. So nagre-review muna kami before proceeding to the hydraulic calculation. So this is your 3 system. Okay. So this is the most ordinary 3 system, di ba? You have your riser, you have your cross main, and you have your branch line. So kung makikita mo, 3. Parang punong ka. Ahoy nga naman talaga. You have ito yung riser nipple mo, ito na yung branch line mo. So, these are fed from one direction. Loop system, kung kikita mo, these are fed from 2 directions. So, nakaloop ngayon ang cross main. Nakaloop ang cross main. Makikita mo yan, nakaloop ang cross main. Pero kung titignan mo, 3 pa rin yan. 3. Hinati lang, no? Kapag gridded system, wala na. Buo na lahat. Yung cross main, pinagdugtong-dugtong na. So, riser, ang mga nomenclatures niya sa pipe protection engineering natin sa basic, this is your riser, this is your feed main, this is your cross main. Yan yung cross main. Ito yung branch line. Okay, sabi ko sa inyo last time, kapag gridded na kayo, kapag ito ay 25 inches, 25 millimeter, 25 millimeter, 25 millimeter na yan. Samantalang ito, hindi. Yan, hindi. Telescopic yan. Maaring ito ay 1 and 1/2. Ito naman ay 1 inch. O 1 and 1/2, 1 and 1/4. This portion sa dulo 1 inch. Telescopic para ma-maintain mo yung pressure. O. Pero kapag gridded na, wala na. Kapag ang ginamit mo ay 40 mm na lahat yan. Kapag sa design mo. Density area method. Okay, so balik tayo ulit dito. This is the most commonly used sprinkler design. So always, the flow of a single sprinkler is Q is given by the formula Q equals density times the area of the sprinkler operation. Yung una. Now, formula again. The total number of sprinklers to calculate is given by the design area over or divide by the area per sprinkler. Ano yung area per sprinkler? Yan yung coverage ng isang sprinkler. Bawat isang sprinkler, ilan ba ang kaya niya? 130, 125? So nasa kwan yun, nasa data yun. Nasa manual din naman, narito sa NFPA 13 din naman. Ikaw ang pipili minsan nun. Okay. Design area, ikaw ang pipili. Bilang designer, ikaw ang pipili ng design area mo. Then, ilang sprinklers in a branch line is given by the formula 1.2 times the square root of the design area over the distance between sprinklers on a branch line. So, S, distance of sprinklers in a branch line. Okay. Room design method. Okay. So pasadahan ulit natin yung room design method kasi baka kung nakalimutan natin. So, in using room design method, we have to calculate all sprinklers in the most demanding area or demanding room, which is usually the largest. Problem lang, hindi naman talaga dinefine ni NFPA 13 kung ano yung room kasi 'di ba? Yung may mga may mga kulatilya ang room design method. Kailangan mong isali yung katabing room, yung dalawang sprinkler heads ng katabing room. Then walls, kung gagamitin mo ang room design method, walls ay dapat fire rated, equivalent, at ang rating niya, kung ilang minutes siyang rated, ay equivalent dapat siya sa water supply duration. So kung light hazard ang iyong building at gagamitan mo siya ng room design method, lahat ng walls niya dapat ay 30 minutes. Ibig sabihin, walang plywood dyan, mga PICIM board dyan. Kapag 90 to 120 minutes, extra hazard, dapat yan, mga semento, mga hollow blocks. Now, ang mga requirements sa room design method is, una, is doors for the light hazard, doors must have automatic or self-closing. Then, calculations must include 2 sprinklers from each adjoining or communicating space. For ordinary hazard and extra hazard, doors must have automatic or self-closers with fire rating. At ang fire rating niya ay nakadepende dito sa dalawang ito, 60 to 90, 90 to 120. And the corridors or the narrow, when protected with a single row sprinklers, calculate maximum 5 sa mga hallways, sa corridors, sa narrow rooms. 5 sprinklers or 75 feet. Kung ilan ang kasya doon sa 75 feet na yon. But maximum of 5. Okay. Hydraulically most remote sprinklers. Usually, it is the highest and farthest from the riser. So, huwag kayo malito. Unang hanapin nyo, saan ko ilalagay ang riser? Kapag kinilagay ko ang riser ko sa kaliwa, titingin ako ngayon sa kanan. Kasi nando sa kanan ang farthest ko. So, kung 10-story building to, nasa kanang parte, on the 10th floor, ang aking farthest. So, always with respect to your fire pump and and riser. So, sabi dito, the location of most remote sprinklers is hard to locate and the gridded systems. Now, let's start. Ilan na nasa loob? 55. So let's start. So just in time, sa mga bagong ins pa lang, welcome to the module 3, to our last session on hydraulic calculations. So, ang hydraulic calculation ng sinasabi ng NFA 13 ay may form. May form, naka-Excel form yan kung magka-calculate tayo ng mano-mano, Excel form. Pero dito, hindi ko i-represent ang Excel form. Iisa-isahin ko talaga yung process para maintindihan natin. Now, ito rin yung form na isasabit natin sa Bureau of Fire. Kasi sabi ng Fire Code, sundan natin. Naka-mandate sa Fire Code na dapat ang gamitin natin ay yung NFPA 13 pagdating sa design. Karamihan yan sa mga plan evaluator ng Bureau of Fire ay mga engineers na. At sila unang-unang at marurunong na sila nito. Lalo na sa mga highly urbanized cities, pag binigyan mo sila ng basta-basta lang na calculation, i-check agad nila yon. Lalo na ngayon sa new fire code, na sinasabi ng bagong fire code, dapat mayroong FSCR, Fire Safety Compliance Report. At isa sa mga compliance report na ilalagay mo doon ay hydraulic calculations. At ang paperman, the one who will sign your Fire Safety Compliance Report is a Fire Safety Practitioner. At ang Fire Safety Practitioner na yon ay engineer or architect. Wala nang iba. Bago naman bigyan ng Certificate of Competency si Fire Safety Practitioner na engineer or architect, iti-testing yan ng Bureau of Fire. At ang mag-i-issue lang yung COC na yan ay ang National Headquarters. So, ganun na siya kahigpit ngayon. So, it is a must, tamang-tama lang na nag-aaral tayo nito. Because darating pala ang panahon na maski anong palusot natin sa calculation, yung mga lumusot tayo mga nauna, hindi na uubra ngayon. Lalo pat may bago na tayong revised implementing rules and regulations ng ating fire code. Okay guys? Now, let me put the overview of hydraulic calculation using the density area method. Okay, so ito yung gagamitin natin, density area method. First thing to do is we need to determine how much water and energy it will take to control a fire. Ayaw natin kasing unang-una ay ma-overpower ng fire ang ating design. Otherwise, failure yun. At responsibilidad yun for 50 years ng isang designer. Then we will make sure that the systems we are designing or reviewing will deliver what they are called on, what they are up to. Now, we have 8 steps for the design for hydraulic calculating a fire sprinkler system. So, hindi ko na yun babasahin isa-isa yung 8 steps na yan, kundi ipapakita ko na sa inyo kung ano yung mga actual na step. Unang step dyan is the select an appropriate design area or flow pressure strategy for the system to be analyzed. Okay, so puntahan natin yan. Before we can do that, I would like to give you a sample project para naman iisa ang ating pag-uusapan. Madibilis lang. Sample project tayo. The sample project is a small building owned by a company that processes and distributes fruit juices or fruit beverages. Fruit juice beverage will be protected with a wet pipe sprinkler system. So, bigay na yung wet pipe daw. The 3,792 square feet building will be used to fill small cans of fruit juices. Okay. The system will be designed to protect an ordinary hazard group 1. So, binigay na para di na tayo mag-1. So, sample project lang naman. Ordinary hazard group 1. Occupancy in accordance with 2016 edition of... Okay, sorry. Pero ng 2019 ngayon. The latest one is 2019. So, wala pa ako. Di ko pa na-secure yun. 2020 na. Dapat pala ma-secure ko na yan. The sprinkler system will use quick response sprinklers having a 1/2 inch NPT connection and a 5.6 K factor. First, don't worry, kukunti lang naman, na-review na ng aking mga kaibigan kasi sa fire protection industry, yung 2019, kukunti lang naman yung pagbabago. Halos din sa presentations na to, well, don't worry, kung ano yung process dito, yan din yung process ng 2019 edition. Now, Binigay dito sa problem natin na ang ating sprinkler head ay 1/2 NPT. So 1/2 quick response. O, tandaan natin na sabi natin kapag quick response, dapat magkaroon tayo ng area adjustment sa design. Yung area na yon, yan yung design. Whenever area is considered, that means design area. Whenever we talk of design area, ibig sabihin, yung farthest, yung remotest area. Yun yung design area mo. If you have an area, a total floor area of, say, 5,000 square foot, hindi mo i-design yung buong 5,000 lang. Yung buong 5,000. Yung design area mo lang. Di ba ang design area? 1,005, 2,000, 2,005. Yung nasa density area curve. Yun lang yung design area mo. Now, we are given also with 5.6K factor. Another given, the piping will be black steel pipe or BI pipe, schedule 40. The branch line will use cast iron threaded fittings and cross main will use cast iron groove fittings. The riser will use cast iron flange fittings except at the top of the riser where it meets with the cross main. The system riser will have a flange type OSNY outside screw in yoke gate valve as its control valve. The system riser will also have a flange swing check valve with gauges and drain. So binigyan na tayo na may gate valve at saka may check valve yung riser. Saan niya nakalagay? Of course, sa baba, sa bottom. The design engineer determined that the available water supply for this building will have a static pressure of 72 PSI. Ibig sabihin, yung water supply ni Maynilad or nung water concessionaire, ang nakalagay dyan ay 72 PSI. And a residual pressure kapag mga gumagamit na at peak load, gumagamit na, marami na gumagamit, natitirahan na lang siya ng 58 PSI. So, binigay na, sinukat na, with 1,200 GPM flowing. So, yun yung water supply available. Ibig sabihin, water supply, hindi yan water tank, hindi yan fire water tank, water supply, galing yan sa water concessionaire. Kailangan mo talagang kunin ang static and residual pressure. When you are designing, unang-unang gagawin talaga ay kunin muna yan. Kasi nakadepende ngayon dyan yung size ng fire pump mo. Kapag inassume mo kasi 0 PSI yan at sisip-sip talaga ang fire pump mo ulit dyan, lalaki ang fire pump mo. Pero since meron ka ng static at residual, meron ka ng stock na pressure. So, liliit ang fire pump requirement mo. Kumbaga, itutulak na lang ng fire pump. However, hindi fire pump ang ating ang ating topic. The supply has been adjusted to represent the water available at the base of the riser. The authority having jurisdiction required allowance for fire department hoses should be added at the base of the riser. So, that's our problem. So, we are given, again, wet pipe sprinkler system, 372 square foot building, ordinary siya sa group 1, ang sprinkler heads niya, quick response sprinklers, scale factor, schedule 40, BI pipe, those are the given, threaded fittings, so cast iron, cross main, yung mga nabibili natin malleable iron, almost cast iron din naman yun, ang treatment natin para. Then your system riser will have OSNY gate valve and the swing check valve. Then you'll have water supply, static pressure of 72 and residual pressure of 58 with 1,200 GPM flowing. Then kailangan mo daw magdagdag ng fire department hoses at the base of the riser. Okay, let's now proceed with the design. The step 1. So there are 8-step process. So, inilagay ko na dito, step 1. So, select the appropriate density area or flow pressure strategy for our system. Sabi ni Chapter 11, the common design approach for our sample project. The strategy of approaches are given as follows. Hydraulic calculation method, density area method. Ito ang gamitin natin. Wag na yan. Next is, for our project, we have been told that this building is ordinary hazard group 1. So, sabi ng ating figure, ordinary hazard group 1. So, gagamit tayo ng 0.15. Ito yung design area. O, gaano mo siya kalaki, di ba? Di ba? 3,000? Ilan niya yun? 3,500. 3,700. 92 square foot. Ang design area mo lang is 1,500. Yung pinakamalayo, 1,500. Ito yung pinakatipid kasi, 1,500 to 2,000. So yan ang pinakatipid. Pwede ka na maggamit ng 2,500, ng 3,000, pero hindi yan tipid. Dito tayo sa pinakatipid. Na hindi naman ang sacrifice yung code, yung standards. So from now, we will call that as 0.15 over 1,500. 0.15 GPM over 1,500 square foot. Next, step 2. So, determine the coverage area of each sprinklers. Sa isang sprinkler, ilan daw? Okay. Our strategies for calculating a system require us to know something about the area that each sprinkler is expected to protect. This is called the individual sprinkler's area of protection or area of operations. Other literature calls it area of operation. A sprinkler's area of protection is often referred to as the coverage area of sprinklers. When you say coverage area, yan yung kayang makover ng isang sprinkler. Coverage area. Chapter 8 of NFPA tells us how large the area coverage area can be. Now, when trying to determine how much area a sprinkler covers, we usually start with section 8.5.2 of NFPA 13. This section is titled Protection Areas per Sprinkler. And among other things, it explains something called the SL rule. Okay. Ito yung protection area ng isang sprinkler. So, maski hindi siya ibigay ng inyong manufacturer, dito lang kayo pipili. 130, 168, 130. Bakit? Yan ang ginagamit ko. Hindi ako gumagamit ng pipe schedule. Hindi na. So, ekes na to. Pambihira naman itong combustible, unobstructed with exposed members, pambihira to. Ito ay mga residential, mga apartment. Ay, ang laki-laki, 225. Usually, pag commercial, dito lang siya. 130, 168, dalawa lang. So, gumagamit pa ako ng 120. Yes, kapag may mga concealed spaces, ibig sabihin may mga nakatago. Yung sprinkler head mo, ilalagay mo sa taas, maraming babanggaan, maraming mga bakal na dadaanan. Kaya yung sa baba, maski ordinary hazard or light hazard, kung may concealed spaces ka, naging 11.1. Yung mga attic is concealed spaces yun. Di ba? Basta, may posibilidad na masunog, may daanan ng tao, may penetrations ng mga ducting, may mga clean out, or may mga manhole, yun ay concealed spaces. Siyang mo gagamitin na pambira naman yun. So, nilagay ko, don't make no mistake, ito nilagyan ko ng pula, ang sinasabi ko dito, ayan ang kalimitan ginagamit ko kapag ako nagdi-design, either 130 or 168. Now, maximum spacing, ito sinasabi ko, you are allowed sprinkler head to sprinkler in a branch line maximum of 4.6. Pero never kung ginagamit ang 4.6. Nakagamit ako 3.5, 4, yes, but never 4.6. Ang kanang kalimitan ko ay 3. Okay, magastos ang 3 kasi dikit-dikit. You are allowed 4 actually, 3.5. We are doing that. Sa mga kontraktor, lalo pa sa mga kontraktor na nandito, hindi karamihan hindi gumagamit ng 3. Pero yun naman pinakamatipid sa tubo. Pero pagdating naman sa spacing, mas matipid yung 4 o 3.5. Alright. Nabanggit kanina yung SL rule. This rule states that the protection area of a sprinkler is equal to the space between sprinklers along the branch line S multiplied by the space between the branch lines L. Ano yun? Along the branch line, yan. Then, space between the branch line, ito yung unang branch line, ito yung unang branch line, ito yung pangalawang branch line. So, yan. So, para gumagano na. Now, we choose the spacing for S from one of the following. So, may kwan dito. Distance between sprinklers or the distance to the wall times 2. Times 2. Okay. Now, always choose the number from these options that result to the largest distance. Kung i-design na natin yung problem kanina, yung sample problem, ito yung mangyayari sa isang area ninyo. ito yung gagawin nyo. This is not the 3,500. This is not the 3,500. Design area lang muna, 1,500 ang ini-imagine natin. Yung maliit lang, 1,500 because yan yung work natin. Ito yung 1,500. Now, ang unang-unang gagawin natin dyan, maglalagay tayo ng sprinkler head sa dulo sa kanto. Ito. Pinakakanto. Pinakamalayo, pinaka-remote. Bakit 5 feet? Di ba 5 feet is 1.5 meter? Sabi ko sa inyo nga, karamihan, di ba, 3 meters. 3 meters. Hatiin mo, para ang coverage niya ngayon, pag ginawa mo na siyang ganon, binilog-bilogan mo na siya, yan ang sprinkler coverage area. O, the 5 meter, 5 feet is 1.5. 4 inch doon. So, nilapit na. Kasi dikit na dikit naman dito. So, 4 feet pala. Sorry, 4 feet. Okay pa rin yun. 1.2 meters, okay pa rin. 1 meter, okay pa rin. Walang problema pa. Cover na cover. Lalo pa, halimbawa, kung pag-design nyo, yan ay mga salamin. Ito ay mga glasses na may mga kortina. Ay ilapit-lapit mo dyan ang sprinklers ninyo. Bakit? Para pag nasunog ang kortina, madali lang. O, ganun yun. Kaya yung investigation sa mga lalagyan nyo, importante. Paano naman ang tanong kung bago, puro palang drawing, ikaw ka mo ngayon, i-assume mo ang worst. Pwede itong ganito, 4 and 5. Okay, now, ilalagay mo na siya dyan. Maglagay ka lang muna. Ang spacing ngayon ay 14 feet. 14 feet ang spacing. Sprinkler, 14 feet, 14 feet, then 14 feet. Then, cross mo. So, drawing mo na to. Pwede pa maglagay ka pa dito ulit. Kumbaga, hinaba mo ito masyado. Pwede yan. Lagay ka pa dito ulit. Habang nag-drawing ka. Pwede yan ganyan. Pero for the purpose kasi, 1,500, kailangan natin. Ito lang yung na-cover mo. 1,500. Yan lang muna. Okay. Next. A sprinkler's area of protection, often referred to as the coverage area of one sprinkler, is represented by AS. Determine the S. The spacing along the branch line. Spacing along the branch line. Determine the L. The spacing between the branch line. Okay. Now, tingnan nyo to. Gaano kalayo ito at saka dito? Yan. 9 feet. 5 feet. 14 feet. 14 feet. 5 feet. 9 feet. 9 feet. Di ba? So, yun ang, kumbaga, yun ang ng designer. Tanong, pwede ba yan? Pwede. It's your option. Para hindi kayo makuhan. Para hindi kayo malito. 9 feet, bakit hindi pa ginawang 10 feet para 3 meters? Aesthetic yan eh. Diba dito, mayroon naman dito, itong putol. Ibig sabihin yan, continuous yan. Putol yan. Ibig sabihin, pakagawa niyan, continuous. Marami kang ginawa, may branch line ka pa dito, di na lang pinakita. Kasi hindi mo kailangang i-calculate lahat ng sprinklers na nandyan sa 1,500 na yan eh. Hindi mo kailangan i-calculate ang sprinklers na nandyan sa loob ng ikon yan. Kung ilan lang ang lumabas. So mayroon din yung branch line dyan. May naglagay rin yan dyan. Kasi putol yan, 9 feet is about 2.8, 2.7 meters. So, supposed to be 3 meters na siya. 3 meter, pwede ganon. In-square mo, pwede rin naman ganito. Okay. Now, determine the AS for this sprinkler using the steps we discussed. Again, AS, the coverage area for your one sprinkler. Ito, usually, itong dulo yan. Or one, o ito. Basta isang sprinkler. Now, the first one, twice the distance to the wall. Twice the distance to the wall, 5 times 2 is 10. The distance to the next sprinkler. The distance to the next sprinkler is 14. Therefore, ang gagamitin mo ay 14. Kasi, sabi doon, yung pinakamalaki, the biggest. Yan ang S. Next, L naman tayo. Twice the distance to the wall, 4 feet, 4 times 2 is 8. But, the distance between branch line 1 and branch line 2 is 9. So, 9. Mas malaki ang 9 sa 8. So gagamitin mo, yung L mo ngayon ay 9 feet. Okay, therefore, your SL rule is that the area of coverage of one sprinkler is 14 times 9 is 126. 126 ang coverage ng isang sprinkler mo. Yung isang sprinkler, bawat isa will cover 126 square foot. Okay. Yung iba niyan, pag nagdi-design, binibilog-bilogan yan. 126 square foot. Ganyan. Mag-overlap yan. Dapat, ito, yan ay kukunti lang yan na area na hindi magtama. Dapat nga yan, talaga mag-cover pa yan eh. Ganon, taas. Pag ginagawa niyan. Kung talagang mahigpit na mahigpit yan, hinihingi yan, 0-0 yan. So yan, 126 square foot. The sprinklers we choose as shown in 2.3 has an area of 126 square foot. If you apply the SL rule to each sprinkler shown on the first 3 branch line of our project. Okay. Now, step 3. Nasa 3 na tayo. Determine the arrangement of the system piping, valves, and fittings, including the changes in elevation. Yan yung step 3. We need to know that the branch lines are installed 1 feet below the roof deck. 1 feet below the roof deck. 2.1, figure 2.1 indicates that the roof deck is 20 feet above. 20 feet above the finished floor. Therefore, this branch line is installed 19 feet above the floor, or 19 feet AFF. Okay. This same exhibit also indicates that the cross main is located 3 feet below the branch line. 3 feet below the branch line. Ibig sabihin, there's a riser main that is 3 feet, or a riser nipple. Therefore, the cross main will be installed at 16 feet. Okay. Ito yan, parang ganito yan. Para di tayo malito. Kasi ang hirap ng English na yun eh. Ito yan. So, 15 feet, 20 feet. 20 feet ito, yung roof deck mo. 1 foot below, nandiyan yung branch line mo. 1 foot below. Then, ito yung cross main mo, tataas uli ng konti ang branch line mo. So, ang tawag natin dyan, sometimes ang iba dyan, ang tawag dyan ay mag-return bend. Pero since ito ay upright, wala na. Tataas talaga. Bakit ito yung cross main, ito yung riser mo. This is your riser. Ito yung cross main mo, bakit kailangan tumaas? Para yung sediments. Hindi magkuhan. Mamaya, ituturo na, ikukumpare natin yan. So, at least na-figure out ninyo yung pagkagawa. Kasi ito yung simula, ito yung medyo critical. Okay. Fittings such as T's and elbows will need to be accounted for in the calculation. Of course, fittings and T's and elbows, the fittings. Kailangan mo yon kasi nawawalan ka ng friction losses doon. Nagkakaroon ka ng friction losses doon. Any valves, pati sa mga valves that occur in the path of water flow will also need to be accounted. OSNY and check pub, nasabi kanina, i-account natin yun because of the friction losses kapag dumaan ang tubig doon. We must identify where there are changes in the direction of water flow, and where the water will travel through the valves and other special devices. Now, step 4, determine the minimum amount of water needed from each individual sprinklers. Okay. Okay, tingnan natin. Kinuha ko yung pinakadulong sprinklers. Ito pinakadulo. Kung titinan mo yung pinakadulong sprinklers na, di ba ang kailangan natin is 126 square foot. 126 square foot. Pero kung titinan mo, 5 feet from the wall, di ba 14 inches siya, 14 feet, 14. So hatiin mo siya, 7. So that makes 12. 4 feet ito ay 4 feet and 6 inches or 4.5 because ito ay 9. Diba 9? Kalahati ng 9 is 4.5. O ito, 4.5. 4.5 feet. Okay. Pasensya na ulit doon sa mga metric ha kasi English talaga ang inyong Alex eh. Okay. 8.5 feet. Okay. Pag minultiply mo itong dalawa, this one at saka this one, it will give you only 102. square foot. Now, paano yan? Dapat daw 126. Paano yan? 102 lang, kapos. Dapat daw 126. Okay. Huwag mag-alala kasi nato yan. Since we know that the coverage area of a sprinkler and density that is required, we can determine the total amount of water that must come out from sprinkler. Thus, the total amount of water that must flow from sprinkler QS is determined by multiplying AS. So ito na yan. Kailangan mo na ito 126 times the density. So, okay. 126 times the density, 18.9 GPM. 18.9 ang lalabas ngayon dito sa isang sprinklers na yan. Sa isang sprinkler na yan, rather. Next, step 5. At least, i-park mo na yun sa isip mo. We have 102 pero ang requirement, dapat 126. That's the minimum. Ibig sabihin, yung 102 ko nakuha, bagsak yun. 126 ang minimum eh. Then, kailangan ko ng 18.5. Okay, i-park mo muna yan kasi babalikan natin yan. Step 5, determine which sprinklers will open in a fire remote area and which will be the most demanding of the water supply. So step 1, we selected the area of sprinkler operation of 1,500. So yung unang ginawa natin sa step 1. Galing yan sa 112311 sa density area curve na figure 11. Then, alam natin na ordinary group 1 hazard siya. Then, the remote area could also be considered to indicate the area of a fire where we would be expected to control using the occupancy hazard control approach. When using the density area method of 1123 of NFPA 13, we are told to adjust the size of the remote area without changing the density for different situations that might exist in the buildings that we are protected. Okay, we are told to adjust. One of the adjustment is that quick response, di ba? Quick response. Sometimes we are told to reduce the area or to increase the area depending on the scenario. Kapag gumamit ka ng quick response, pwede ka mag-reduce. Now, sabi ng 112325 requires us to increase the size of the remote area by 30% to accommodate the delay in water. Kapag ikaw ay gagamit ng dry pipe or double interlock pre-action, hindi naman tayo gumamit ng dry pipe. Gumamit tayo ng wet pipe. So, wala na siya. Pinapakita ko lang dito sa inyo yung kung paano yung mga maaaring applications na ma-encounter niyo. If the system you are calculating is of the dry or double interlock type, then idadagdaga yung 1,500, dadagdaga mo ng 30%, magiging 1,950 kung sakali man. So, pero hindi naman. Sa problem natin, hindi. Okay. Next, we are going to use quick response. Sabi dito sa sample project. Then, ibig sabihin, this will be allowed using this among other conditions, the fire would need to be in a less than challenging occupancy. Using this allowance, we might actually consider a fire that is up to 40% smaller than the size of the remote area. Because we are using quick response, we are allowed up to 40% smaller. Sabi ng NFPA 13. Now, basta dapat yung pag lumit na ng tudong yun, remote area natin yun, wag naman is at least 3,000 square foot in size kapag mayroong mga combustible and concealed spaces. So, ibig sabihin, kapag yun ang laman doon, sinabi doon sa natin, may mga combustible and concealed spaces, obligado tayo, ang pinakamaliit natin, pag na-reduce natin, 3,000 square foot. Okay. For this project, the only area reduction that we can apply is the use of quick response sprinklers. Sabi kasi ng 112323, dapat it must be wet pipe. Check, wet pipe tayo. The occupancy must be of light or ordinary hazard. Ordinary hazard tayo. So check. The highest point on the ceiling can be no more than 20 feet. No more than 20 feet tayo. Check. There must be no unprotected ceiling packets larger than 32. Wala naman sinabi ganun. So let's assume na wala, na tayo. So pasok tayo dito. Pero sinasabi dito, no more than 32 square foot as allowed in 867-887. So, puntahan natin yung 867-887 para at least alam nyo. Sabi na 867, sprinklers shall not be required in ceiling packets, shall not be required, hindi mo kailangan ng sprinkler sa mga ceiling packets where all of the following are met. The total volume of the unprotected ceiling packets does not exceed 28.3 cubic meter. So, 28.3, ito yung mga sprinklers mo. Ito yung mga ceiling packets mo. Pagka-design. Hindi ka na kailangan maglagay ng sprinkler dito kung yan ay less than 28.3 square meter. Wala na dito. Kung yan 28.3. The entire floor under the protected ceiling packet is protected by sprinklers at the lower ceiling elevation. So, yan. Meron ka ng lower ceiling elevation, meron na. And the total size of all unprotected is less than, do not exceed 28.3. At gumamit ng quick response sprinklers throughout the compartment. 887. Ang sabi ng 887, sprinklers shall not be required in ceiling packets where all of the following area are met. Halos parehas lang. Ng kabila. So, ibig sabihin, lusot tayo. Pwede tayo gumamit ngayon ng reduction kasi wala tayo ceiling packets. Now, let's go back to our sample project. We are allowed, we can reduce the remote area of our project by 25% because we have a 20 feet high ceiling. Bakit 25%? Your ceiling height is 20 feet. Ito. Ang percentage reduction to the design area is 25%. Ito yon, 25%. So, ibig sabihin, mag-a-apply na tayo sa 1,500 natin, bawasan natin ng 25%, then it becomes, ang ating design area na lang ngayon ay 1,125. So, mas lumiit, mas maganda, mas naging tipid. 1,125. Okay. Ano ngayon kung may 1,125 square meter na tayo? Di ba 126 dati naging 102? Ngayon, hindi na pala 126, 1,125 na. 1,125 square foot na. At ang isa ngayon ay 126 square foot. Ang isa, 126 square feet. At ang design area mo is 1,125 square feet. Okay. Now, ano ngayon ang size? Shape na yung design area. Ang design area mo ay ang remotest area and ang most challenging mo. You have a 10th floor, 20-story building. On your left is your riser. Ang pinaka-remotest mo at ang magiging design area mo ay yung challenging area mo. At ang most challenging area mo ay yung nasa right side mo at yung nasa 10th floor. Yan. Ano ang size? Sabi ng NFPA 13, ang size niyan dapat daw ay ito, rectangle. L, na kung saan ang length ay L, 1.2 times the square root of A. Hindi ganito. Pahaba, para mas challenging sa sprinklers. Dahil dito, ito ay isa din sa mga safety factors, kaya wala nang ginagamit na safety factor kapag katapos ng calculation. Alright. This calculation would be fine if the fire will grow symmetrically. But as we do with everything and calculating the fire sprinkler systems, we should account for the fire that grows in a way that is challenging to the sprinkler system. So rather than having the length of the remote area L equal to the square root of the remote area, we could make the remote area longer. And to make it longer, dagdag ka ng 20%. Itong 20% na to, ito yung mga factors na sinasabi ko kanina na hindi mo na kailangan pang magdagdag ng safety factor pagkatapos because una, mayroon ka na dito sa roughness coefficient. Pangalawa, mayroon ka na naman ngayon dito sa design area na 20%. Okay. Supposed to be, tingnan mo naman, kung ang ginamit natin na square, so ang nakalaman lang sa kanya ay 3. Diba? 3 lang to. Samantalang kung sa kanya ngayon ay 4 na. Pinaliit mo siya. Mas maliit nga siya, kumbaga mas mababa ang height niya, pero mas naging compact naman siya o mas naging what do you call that? Dumami. Mas dumami. And hindi naman yan hinula because sinabi yan ng 234411. The design area shall be rectangular area having a dimension parallel to the branch line at least 1.2 times the square root of the area of sprinkler operations. O yan yan. Next. Ilan yan? Sa problem natin, 1.2 times the square root of 1125 is 40 feet and 3 inches or 40.25. O 40.25. So mayroon na tayong idea, 40.25. Kung 40.25 yan, kung 1125 yan, i-divide mo ng kung 1125 yan, i-divide mo ng 126. Therefore, kailangan natin ng 9 sprinkler heads. Doon mismo sa design area, di ba? Una, ang design area natin 1,500. And kung ang laman nun, pag nilagay mo na ngayon yung mga sprinkler heads mo, baka umabot ka ng 12, 15, hindi mo kailangan i-design yung 12, yung 15. Kailangan mo lang ng siyam. Saan mo nakuha yung siyam? Dito yan. Remote area, divide by the sprinkler coverage of 1 sprinkler. So you have 9. So kung ito ay 8.1, still ang gagamitin mo 9. Ito ang round off, yung rules ng round off. Kung 8.05, 9 pa rin ang gagamitin mo. Bakit? Life safety. Fire safety ang pinag-uusapan natin. Hindi dito umuobra ngayon yung round off rule. Laging 1. So kung 7.8, din 8 ka. Anything higher than 8, 9 ka. Ano na? Oh. So we will need to open at least 9 sprinklers. Now, next step is to determine where the shape of our remote area will be placed on our system. We should place it away from the water supply and in a place that will be the most challenging to get water to the sprinklers that will open within our remote area shape. O, yun. Talaga ilayo mo siya doon sa source of water mo para mas magiging demanding o mas magiging challenging sa fire pump. Sa system. So, okay. Next. This is another catch. The length must be 4 feet or 4.25. 4 feet and 3 inches along the branch line. Sabi dito, use the power point of this sprinkler's area of coverage to lay out the shape of 1125. Now, the length of the remote area, L, needed to be at least 40.25. That would mean we should draw a line from the far corner of the building as shown. Mula dito daw, hanggang doon mag-drawing ka. At kukunin mo ngayon ang 4.25. Kapag, sabi ng NFPA, kapag lumampas sa gitna ng dalawang sprinkler head, ang length na yan, magdagdag ka ng isang sprinkler head dito. Huwag lang itong tatlong to. 1, 2, 3. Lumampas eh. Pag lumampas sa gitna ng dalawang sprinkler head, lumampas sa gitna, lampas ng kunting-kunting lampas lang, magdagdag ka ng isa. Yan. That's the reason why mayroon ka pang isa ngayon dito. Dagdag ka ng isa. Kapag ganyan ang dinakuan mo at binilang mo na lahat yan, lumalabas pala, it turns out na mayroon kang 52 feet. Okay. Now, next. we, ang tanong, tama na ba yung area natin? Do we have enough coverage area to meet the minimum size of our remote area? Do we have enough cover or enough area to meet the minimum size of our remote area? We will answer that. Ganito. We will need 4 sprinklers on the first branch line. Apat na. 1, 2, 3, 4. All of them on the first branch line. And then another 4 sprinklers on the second branch line. Kasi siyam, di ba? Siyam. Next. Kung 8 na, tanong, saan ko ilalagay ang pang-siyam ko? Dito ko ba ilalagay? Kasi ito yung challenging, ito yung pinaka-remote. Ito bang letter A ang susundin ko? Ano ba sinasabi ng NFPA 13? Kasi kung tutuusin nga naman, sabi puro challenging, puro remote. Eh natapos na ako ng 8, siyam ang kailangan kong sprinklers. Ito ba ang i-consider? Ang i-design ko ba ay ito? Yan ba ang i-design ko? Ganyan ba ang magiging design area ko? Kasi siyam eh. Okay. Sabi ng NFPA ng figure 823.4, sabi dito, the sprinkler closest to the main should be chosen for 3 system. Sabi dito, for 3 and loop system, the extra sprinkler on line 4 should be the one closest to the main. Kung ito yung cross main mo, kung narito ang cross main mo, pinakamalapit. Kung narito ang cross main mo, pinakamalapit. However, kung gridded daw siya, kung gridded system, maski saan? Maski saan? From B, C, D, E. Maski alin siya. Okay. Therefore, we should choose sprinkler C. Ito. Ito yung 9. C as the ninth sprinkler of the remote area. Hindi ito, kundi ito. Pinaka-close sa remote area. Now, our next step is to determine, okay, 9 sprinklers lang di ba? Tanong, ito ba? O ito? Dalawang pinaka-close Una, ito lang, 9. Bakit? Ito yung karamihan. Narito yung karamihan mo. Ito kasi pahabol lang ito Dahil sa rule na nauna kanina, di ba, lumampas sa gitna. So, ito ang sunod mo. So, wag ma-confuse, guys. Ito ang gagamitin mo. Pang 9. Now, tanong. Our next step is to determine if the sprinklers we selected actually cover enough floor space to meet the minimum size of a 1125 square foot remote area. The first thing we will do now is to determine the coverage area of sprinklers 1 to 4. Ito ang coverage area. Ito. Yung sprinkler coverage area ng 1 to 4, ito, di ba, yung shaded na yan. Yan, ano yan? Di ba yan ay 52 feet times 8.5? Bakit 8.5? Bakit 8.5? Di ba ito ay 9 feet? Di 4.5, kalahati. Kasi yan ang coverage, ang kinukuha lang natin ito itong coverage area na to ng branch line 1, yung 4 na yan. Di ba yan lang kinukuha natin, yan. 4.5, kalahati 4.5 plus 4, 8. Ito 4. Plus 4.5, ito kalahati lang kasi 4.5. Kasi ito 9 feet, 'di ba? 9 feet ito guys, 9 feet. Kalahati 4.5. 4.5 plus 4, 8.5. 8.5. 8.5 inches. So, times 52 kasi 52 to, ang haba na yan 52 is 442. Paano ngayon yung branch line 2? Ang branch line 2 naman, the same lang, 52 pero 9 feet. Bakit 9 feet na? Di ba? Guys, 9 feet ito. Kalahati nito, 3 feet. Plus kalahati pa nito kasi 9 feet na naman to. 9 feet yan. Kalahati na naman yan. So ito, at saka yan, 9 feet. O yan, 9 feet yan. Kung 9 feet yan, 2 times 9 is 468. 468. Now, yung isang sprinkler nito, di ba, 126? Ang bawat isang sprinkler head, 126. O, dagdag mo na. 442, 468, o 1306. Kulang. Kulang ang remote area mo. Ang sinasabi, 1125. Kulang. Kung kulang ang remote area, anong gagawin natin? Magdagdag. Gamitin mo tong isang to, dagdagan mo. Paano yan? Sabi, the number of sprinklers to calculate is only 9. Tama. Pero, mali na, kulang. Pag 9 lang ang ginamit mo, ang sinasabi dito, ang design area mo dapat ay 1125. Dapat nga 1,500 eh. Nagkaroon ka ng reduction na naging 1125. Kung ang gagamit mo, ipagpipilitan natin na siyam lang na sprinkler head, kapos. Dito minsan na uula o nawawala ang ibang designers. Kung muna lumabas na sa kanila na 9 sprinkler heads, 9 lang talaga. Yan yung reason kung bakit ang iba gumagana naman ang sprinkler head, pero hindi pa rin control yung spread ng fire. Diretso pa rin. Nauubos or nau-overpower yung sprinklers. Dahil kapos yung design area. Classic example na maaari kong masabi. Ito for purposes of academic discussion lang guys ha. Nasunog, di ba? Sa Cebu, ano yun? Metro, Gaisano, Ayala, Metro Gaisano, si Cebu. Kung doon, nagsimula, dalawang bagay kasi yun eh. Ang maaring causes ng theoretically. Nagsimula sa toy section. Toy section, mga plastic. Na-overpower yung sprinklers. Gumana yung sprinkler, pero hindi na control yung fire. Lumala hanggang inabot ng more than 52 hours, palagay ko, na naubos, di ba? Nasira yung hanggang makarating sa third floor, naubos ang fourth floor, naubos ang second floor. Lumawak na lumawak. Buti nila, walang namatay kasi 9 p.m. na nagsimula ang apoy. Kasi pag dinidesign ng isang mall, yan ay mga open, mga shell. Di mo naman alam bilang designer kung anong mag-occupy dyan, anong magre-renta dyan. Magiging plastic ba yan? Storage area ba yan? Di mo alam, shell pa lang naman yan eh. Another one, na-overpower do, dahil pangalawa, maaaring itong example natin na to, maaaring maliit, hinayaan lang, kung ang lumabas ay kanya ay 9 sprinklers head, sa computer, total number of sprinklers to calculate, 9 lang, ay hindi siya pumunta dito sa mga area na to. Kapos. Balik tayo dito sa ko natin. Anong gagawin natin? Kapos. Didagdagan natin kasi ang requirement po 1125. Magdagdag ka ng isa. Kung magdagdag ako ng isa, ano daw yun? Magdagdag ako ng 10. 12 feet times 9 feet. Bakit naman naging 12 feet? Di kanto kasi yan eh. 7 plus 5. Ganito din 5. Plus, nariyan yung 5 pala eh. 5, 12. Nariyan yung 12. Nasaan yun naman yung 9? Di ba ito 9? 9 feet ito. 9. This 108. Dagdag mo na ngayon doon sa 1036 mo, di 1144. Kung 1144, ang requirement mo lang naman is 1125, di ba? Mali ito, dapat ito 5. Ang requirement mo lang naman ay 1125, 1144, di okay na. Ang design area mo ngayon, kasi ito yung minimum. 1125 is your minimum design area. Pumasok ka na sa 1144, okay na. Ibig sabihin, the total number of sprinklers to calculate is not 9, but 10. 10. Okay. Pasok na tayo. 6 na tayo. Determine which single sprinkler will be the most demanding and then determine the primary water path and any attachment path. So, water path na tayo. Papasok na tayo sa calculation proper. Kasi tapos na tayo sa design area. Primary water path and attachment paths. So, importante malaman yan. So, dito na tayo. And then, para malaman mo yan, yung mga path na yan, kailangan mo maglagay ng nodes. Okay. Kailangan mo na maglagay ng mga reference point called node when performing the hydraulic calculation. A node is any point on the system to which we assign a label. Usually, nodes are the endpoints of a piece of pipe. Halimbawa, from 4-inch, naging 3-inch, yung pagdugtong na yon, pagkaroon mo ng reducer doon, yun, may isang node doon. Halimbawa, ganon. Nodes can also be placed at the connection points to the bulbs, to any flowing sprinklers, and any other system devices. By using nodes to describe the path that the water flows, we can break the system into manageable parts so we can determine how much energy we need to push water through the system. Okay. So, where do we need to place the nodes on the system? Sabi ng NFPA 13, there are 4 criteria to determine the location of the nodes or where the nodes will be required. Una, open sprinklers. Mga sprinklers daw sa Mag-oo. Any point where the water flows away from the primary path. So, you have a primary path, may water flow na pwedeng lumabas sa primary path. Node yun. Any change in pipe diameter. Lumiit yung nagkaroon ka ng schedule 30, bigla, node, pwede rin yun. Any change in internal roughness. So, gumamit ka ng BI, then GI. Kung nung GI ka, nung pag-ship mo sa GI, sa kadugtong na GI, another node yun. Kasi ibang C-factor yun. So, yan ang kanya. Alright. So, lagyan natin ngayon. Because in our sample problem, there are no internal roughness chains. So, walang chains. So, ilalagay lang natin ngayon ng numbers. Sabi, sprinklers is a node. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, may node ka na. 10. Next node. Diba ito yung cross main mo kasi. Cross main. Ito branch line. Ito ay branch line 1, branch line 2, branch line 3. So, ito ay cross main mo. Ito yung bottom of riser mo. BOR, bottom of riser. So, sa baba, kung ito ay detress, kasi nandiyan 3-inch. Detress, ito 1 in 1/4 na tubo, ito 1 in 1/4 na tubo, ito 1 inch na tubo. 1 inch na tubo. So, sa baba niyan, paakyat. Yung sa baba niyan, sabi daw, 1 in 1/2. Pero ang taas niya, 3 inch. 3 inch. 3 feet, sorry, 3 feet. So, yan ay cross main 1. Dito sa taas, riser nipple 1. So, parehas, riser nipple 2, cross main 2 sa baba. Riser nipple 3, cross main 3. So, yan. Okay. Next is, wait. Do you need a break, guys? Break muna tayo ng 3 minutes, ha? Kasi gusto ko lang uminom, namamalat na ako eh. Mamalat ako. Break muna, guys. Break muna kasi medyo ko na tayo. Just give me 2-3 minutes. Thank you. Ami, break muna kami, Ami. Ami?
Mabilis eh. Di ba?
Please send po to everybody. Thank you po. Please send po to everybody. Thank you po.
Sige. Thank you.
Alright.
Tweet type, mga ganon, mga look type.
Hindi alam yung principles behind. Okay,
Ito pa si Ikad, Mare.
pwede tayo.
Alright po.
Are we good, guys? Pwede na. Okay na. Okay, sige, thank you. Okay, so ito pa lang, hindi ko lang nabanggit sa inyo kanina. Maaring sa iba, sa millennial, sabi, bili na lang ako ng software. Tama naman yun, pero may nakilala kasi akong mga batang engineers pa, hindi alam yung principles behind eh. Ito, kaya ito ginagawa ni PSM eh. Una-una, dahil di naman to tinuro sa college. Kung aasahan lang natin yung software. Bukod pa, napakamahal ng software. Ako ang may software ako ginagamit. Nasa $1,500. Pero may isang software talagang maganda. Yung AutoCAD mo, papasok mo na sa kanya, $10,000 yun eh. Yung isang software na yun. Tapos you have an annual renewal pa no, na nasa $2,000 ang annual renewal mo. Sprinkler, talaga maganda. Yan lang, ganun naman kalaki ang yung investment cost sa software. Kasi license. Okay. So, iba pa rin kapag ganito. Kasi minsan, nai-enjoy pag compute. Kaya itong binibigay ko sa inyo, partners, ay talagang deepest. Kumbaga, paano maintindihan talaga kung paano. Pero, okay, pinakasimple na pwede kong maikwento. Kasi mahirap yung magkwento nito na walang ganitong guide. Now, let's proceed. Una, kapag kayo magkakalculate na, you have to be the water. Kailangan isipin nyo kayo ang tubig para alam nyo ngayon kung saan kayo pupunta. You have to be a water. Okay. For you to, as you try to determine the paths and nodes and the node placement, you have to imagine yourself traveling through the piping. Okay. Now, if you are the water, saan kaya kayo pupunta para marating nyo ang pinaka-remote na sprinkler head, which is 1. Diba? Kung kayo galing sa bottom of riser, pupunta kayo dito, dadaanan nyo ang cross main 3, dadaanan nyo ang cross main 2, dadaanan nyo ang cross main 1, pupunta ka ngayon doon. Yan ang pinaka-shortest distance para sa'yo. Ibig sabihin, yan ang primary path mo. Ang primary path mo ay 1, kasi pabaliktad ang pag-compute nito eh. Kasi, pag nakarating ka ngayon sa baba, saka mo lang masa-size up ang requirement mo sa fire pump. Ito ang purpose nito. Fire pump ang end result nito. So, 1, 2, 3, then riser nipple 1, sa taas, riser nipple, bababa ka ngayon sa riser nipple, babagsak ka sa cross main 1, cross main 2, cross main 3, to bottom of riser. Yan ang primary path. Now, ano ngayon ang tawag ngayon dito sa CM3, sa pupunta ngayon sa sprinkler head number 9, sa number 10, at saka sa branch line 2. Yun, ang tawag naman ngayon dyan ay attachment path. Paano ngayon yung papunta ngayon dito? Branch line 1 yan. Hindi. At yung sprinkler head number 4 dito, attachment path pa rin yun. So mayroon kayong tatlong attachment path. Una, yung nandito sa branch line 2, at saka itong dalawang ito. Yan ang tatlong attachment path. Ang primary path natin ay ito. Yan yung primary paths. O at least. Kung pagdaan mo, ito yan. Ito na. Yan yung 3D. So, primary path is 1, 2, 3. Right, sir, nipple 1. Bababa ka ngayon. Diba, bababa ka. Cross main 1, cross main 2, cross main 3. Karating ka ngayon dito sa bottom of riser. Oh, yan yung primary path. All the other paths, yung palabas ngayon dito, outlet, ito kasi, itong riser nipple, itong 4 na to, is output, outflow, palabas sa primary path. So, attachment path, yung pag-akyat ngayon dyan, at saka pagpunta attachment path, yung pag-akyat ngayon dyan, is attachment path. At, kung attachment path sila, pagdating ngayon dito, yung ibang tubig pupunta dito, yung ibang tubig pupunta ngayon dito, kung ikaw ang tubig, ilan ang kailangan mong flow at saka pressure para equal pagdating ngayon dito kasi maghahati ngayon dito ilan. So sa mga ganyan, kung saan mayroong attachment path, diyan ka gagawa ng equivalent K-factor. Equivalent K-factor. O dito, ganun din. Kung ikaw ay papunta dito pa diretso, ang equivalent K-factor mo ay dito. Paakyat. At saka ganun din dito. O, yun. Next. The first attachment path. So, bakit attachment path agad ang atake natin? Hindi primary path. Baliktad. Yung alam na natin yung primary path, sa calculation form, sa hydraulic calculation form, doon natin ilalagay yung primary path. Yung attachment path, kailangan natin makuha yun kasi yung equivalent K-factor. O kagaya nito, sa 4, una-unang gagawin natin yung first attachment path, which is 4 Rn1. Kasi dito, maghihiwalay ang tubig dito sa may circle na pula. Yung ibang tubig, yung ibang water, will go to 3, 2, and 1. Yung iba go to dito. Now, kung ikaw tubig, saan ba mas madaling pumunta? Para hindi tayo nalilito. Mas madali bang pumunta sa 1? O mas madaling pumunta sa 4? Of course, very obvious. Maski ito mas malaki, maski 1 in 1/4, maski 32 mm, mas maliit ito. Pero maiksi naman ito Maiksi ang travel papunta dito. So kung ako tubig, dito ako unang pupunta. Kaysa ako makarating dito, malayo yun So kung ako mas madali, yun. Doon ka kukuha ngayon ng equivalent K-factor. Yung equivalent K-factor. Yung una, kung saan ka unang makakarating. Kasi sa kwan. Okay. Yan, equivalent K-factor. Next. Okay. To get the equivalent K-factor, we first to calculate the flow and the pressure required in that attachment path. Then we will use that information to determine the equivalent K-factor. Remember the formula? K is equals to Q over the square root of P. So, para makuha mo yung equivalent K-factor dito, kailangan mo ng flow at saka ng pressure. Okay. Now, we will use that equivalent K-factor to represent the outlet in our primary path. So, ito yung primary path natin. Outlet ito, palabas, outlet. And this will be how we ultimately determine how much water would flow from the sprinklers in the attachment path. Okay. Gaya kanina sinabi ko, it is more challenging for water to go through sprinkler 1, ito yung 1, than sprinkler 4. Therefore, ito tayo uuna. Ganun ang pinaka-principle kung saan siya more challenging. Baliktad. Kung more challenging dito, mas mahirap, unahin mo yung madali. Kung ikaw tubig, saan ka mas madali pumunta? Yun. Kung doon ka mas madali pumunta, yun ang kunin mo para makuha mong K-equivalent dito sa kantong to. Okay. The second attachment path where water leaves the primary path is at node CM2, cross main 2, and flows to sprinklers from mula dito, aakyat siya at lalabas siya ngayon. Oh, yan. So, yan ang susunod mong K-factor equivalent. Previously, we will account for this path by describing it as an outlet in the primary path. And we make again another K-factor equivalent to describe all the pipes and fittings in the second attachment path. To determine an equivalent K-factor, we will first calculate the attachment path. Para makuha mo yung K-factor dito, para makuha mo yung K-factor dyan, kailangan mong makompute muna, di ba, is equal always to Q, o information about Q. Tapos, i-divide mo siya sa square root of P. O kailangan mo ng pressure. So, para makuha mo yung K dyan. So, kailangan, yung Q na yan ay Q ng buo. Q ng buo. At pressure ng buo. Na kailangan para matulak yan dyan. Hindi Q ng bawat isa. Kasi nasa baba ka na nasa bottom ka na. Ang equivalent na kukunin natin, nasa bottom. Now, we will use the equivalent K factor to represent the outlet in our primary path, and this will be how we ultimately determine how much water would flow from the sprinklers on the second branch line. Now, if you will recall, kung ano ang flow na requirement, balikan natin to. Kung ano yung flow requirement dito, parehas identical itong dalawa So yun din ang flow requirement. Makukompute mo yung total flow requirement dito, ayun ang gagamitin mo dito kasi identical. Parehas. Ayun ang kwan doon. Next. We need to identify the third attachment path. Ano naman yung, alam na natin yung second attachment path, the third attachment path. This path is where the water leaves the primary path at node CM3, dito sa CM3, and flows to sprinklers 9 to 10. O, di ba? You have sprinkler 9 and sprinkler 10. Okay. Tanong. Kung ikaw tubig, saan ka mas madaling pumunta? Mas madali ka ba makapunta sa 10 o sa 9? Parehas lang naman yan. 7 feet. Mas madali ka makapunta sa 9. Bakit? 1 in 1 port You know? O, di mas buwelo kang pumunta dito sa 9. Dito, 1 inch lang dito. 1 inch diameter. So, mas mahirap ngayon dito. Kung mo mas madaling pumunta sa 9, ito ang gagamitin mo yung 9, yung K factor mo ngayon dito, gagamit ka ngayon ng flow sa 9. Yung Q at saka P na 9. So, ganun yun. So, ang third attachment path mo ay 10 RN3 CM3. Oh, yan. Attachment yun Kasi pupunta ka ng 9, so ang attachment mo sa kabila. Now, water flow RN3 and goes out to 9. So, ito yung RN3 mo. Saan pupunta ang tubig uli? Papunta ng 9 kasi mas madali siya makapunta dyan sa 9. We will need to describe the pipe attachment path. Then, to get the K equivalent, use again the formula Q over the square root of P. Q of what? The Q of the Q of 9 and the pressure of 9. Now, with the sprinkler at node 10 and an equivalent K factor at node RN3, we are all set to describe our third attachment path as 10 RN3. Now we will be prepared to calculate the minimum flow Q and pressure that will be required in the third attachment path. Ay, naulit-ulit lang. Sorry guys, na medyo nalito na ako dyan. Now, knowing all of this, di ba? First, attachment path, calculate. Next, calculate. Third attachment path, calculate. Pag na-calculate mo na yan, ano ang mga product yan? Equivalent K factor dito. Equivalent K factor dito. equivalent K-factor dito. So kung mayroon ka ng tatlo equivalent K-factor, tama yan. Tama yan kasi tatlo lang naman ang attachment path. Then, pag mayroon na, ito na ngayon ang ipapasok mo ngayon sa hydraulic calculation form, yung primary path. Yan lang ang magre-reflect. Okay, let us see. So, step 7. Remember, there are 8 steps. So, step 7 na tayo. Malapit na tayo. Yung step 7, hinati-hati into 14. So, yung mahaba yung step 7. The first is 7.1. Complete a hydraulic analysis form using the data known for your path. Okay. So, puntahan na natin. Huwag na natin ko yan. Ito na, 7.1. The first thing we will do is start entering data onto the hydraulic calculation form. We will use the pipe analysis form for performing calculations manually. So, what is that form? According to figure 23, 351.2D, ito yung form. Okay. So, let's work. Ito yung form na pepermahan ng PME, isa-sign and sealed, at isa-submit together with the design. Ito rin yung hahanapin na form ng fire safety practitioner. Kasi maaari ang fire safety practitioner natin ay ECE, EE, architects. Only licensed architect and engineers are to become fire safety practitioner according to our revised implementing rules and regulations. So ito yung hahanapin. Si PME ang gagawa nito. So now, what is this? Ito, walk through tayo from node 1 to node 2. Yan ang ibig sabihin yan. Yung data 1, data ng node 1. Yung data 2, data ng node 2. So elevation 1, ni node 1, elevation 2 ni node 2. Then the K-factor ng dalawa. Flow added, this is the Q for node 1. Small q, big Q for node 2, the total flow. Nominal ID and the actual ID. Bakit kailangan? Diba, ang kailangan ng ating Hazen-Williams ay actual inside diameter. So that's one. Then the fittings, quantity and length. For example, the total length and fit of the fittings, the fittings itself, elbow, T's, kaya letter F, fittings yan, and the total. Diba lahat, equivalent length of pipe and fit of fittings, fit plus fit equals total fit. Then the C factor. Yung data dito, ang ilalagay mo yung C factor. Yung friction loss per foot of PSI, dito mo siya ilalagay. And dito na yan, total, the elevation, ito yung elevation. Ito yung friction loss. Ito yung friction loss. Okay. So, yan yung pag-navigate yan. Uli, huwag kalimutan na mayroon tayong table 234311, the equivalent pipe length. Okay. Uli, tandaan, tingnan, T or cross. For example, ng 1 inch T, ang equivalent length niyan ay 5 or 1 feet or 1.5 meters. Uli, pagdating sa check valve, gamitin ang check valve na data ng friction loss ng manufacturer. Kung Tyco yan, kung Navco, yun ang kunin nyo. Kung walang ibinigay si Tyco, walang binigay si Kennedy, so ito ang gamitin nyo kasi ito ay average. Average. So yan. Next, standard pipe schedule for an inner diameter dimension. So for example, 1 inch pipe, that's your nominal 1 inch. Ang gamit natin lagi, kalamitan, ay schedule 40 standard. Kasi pag hindi ka gumamit ng schedule 40, pwede ka gumamit ng schedule 80, pwede ka gumamit ng schedule 30. However, kailangan mo ngayon ng equivalent. Magkakaroon ka ng computation sa equivalent length. Kasi itong datang to, itong lahat ng ito ay nakapattern sa schedule 40 steel pipe C factor of 120. So since na ito lang ang available data, kailangan mong magkaroon ng correction kapag hindi ka gagamit ng schedule 40. Now, take a look at this. Schedule 40, 1-inch pipe diameter, ang inside niya is 1.049. Malaki lagi ang inside diameter sa nominal. 1 in 1/2, 50 mm. Schedule 40 standard. Ang inside diameter niya is 1.6. 1.6 ang inside diameter niya. 1.5 lang yan. 1.5, 1.6 siya. So, wag magtaka. Bakit ang inside diameter mas malaki? Eh, ganyan talaga. Schedule 40. Nominal kasi yung 1 in 1/2. That's, yan yung kuha ng ASTM natin. Now, enter the data we know for the first attachment path. Di ba? Attachment path muna tayo. Wag na muna tayo mag-iintindi ngayon sa primary path. Ang ipapas, kaya tayo naglalagay dito para makuha ang equivalent K-factor. Ang equivalent K-factor. So attachment, first attachment path is 4RN1. 4RN1. Node 1 to node 2. The elevation is 19 feet, di ba? 20 feet. 20 feet ang height nito. So, since naiisa lang naman ang elevation nila, 20 feet kasi ito, ang bubong niya ay 20 feet. Sabi, 1 foot below the bubong, 1 feet below this slab, nandiyan yung branch line. So, kaya ito, natirang ito, 19 feet ito. Ito yung 19. Oh, yan, elevation. Then, the K-factor. Ano bang K-factor ng 4? Di ba binigay na quick response, 5.6. O, 5.6 ang K-factor sa problem natin. Ano ang flow? O, ito ang flow. The flow, kapag pinakadulo na sprinkler head, mga dulo, ito, mga dulo yan, ang formula dyan na gagamitin mo ito. Area of sprinkler operations times the density. The area is 126, diba? Tandaan nyo, square foot times the density of 0.15. So, therefore, 18.9 gallon per minute. O, yan na yan. Nakalagay na ngayon dyan, 18.9. Next, nominal ID. The nominal ID is 1 inch. Diba 1 inch to? O yan, 1 inch yan, 1 inch. Ano inside? Ilang fittings? Sa fittings muna tayo. Ilan? Isa. Isang T. 1 T. Bakit? Ito T ito 1 inch. Hello? Unstable connection. Narinig niyo ko?
Yes, sir. Narinig
Please
po.
confirm.
Opo.
Okay.
Yes,
Sige. 1 T. So may isa tayong T doon. O, di ba? Ang 1 inch na T, kanina, 5 feet. O, balikan natin para hindi kayo makuha. 5 feet. O yan, 5 feet. 1 inch na T. Nawalan ka ng 5 feet. O, yan, 5 feet. O, yan. 5 feet. Ang length ng pipe mo, 7 inches. 7 feet. Ayan, 7 feet. 7 feet. 7 plus 5, 12. C-factor 120. Okay ka na sa unang attachment path mo. Nakakuha mo na. Okay. T-fittings. There is a T attached to this pipe dito. And the energy we would lose the pressure by going through that fitting is the same as if we went through 5-inch pipe. Now, tanong, paano yan? 1 inch, 1 in 1 port. Ano ba ang fitting sa nandito? Diba ito, 1 in 1/2 ito? 1 in 1/2 naman yung riser ko na yan. Right, nipple. Ano ang fitting niya? T-reducer na dyan 1 in 1/2 by 1 in 1 port. 1 in 1/2 by 1 in 1 port. Itong T na yan, 1 in 1/2. Pero, bakit ang ginamit na T dito, yung pang 1 inch? Yan kasi kuha niya. Kasi yung 1 in 1 port na dito sa side dito, 1 in 1 port, i-reduce mo into 1 inch. Kaya ang i-consider mo yung pinakamaliit na dimension. Hindi yung 1 in 1/2 by 1 in 1 port. Remember, dito, wala naman tayo dito. Wala tayo dyan, Equal lahat yan, Equal, T or cross flow, wala tayong binigay na T-reducer. Wala. So, pinakamaliit ang gagamitin. Alright. Now, item 7, in the list above has as adding a certain amount of feet of 5 to represent the energy lost when we turn a corner or go through a piece of equivalent that creates model. We turn the corner through T's and elbows. Well-dead outlets, kaya ng well-dulet, are considered T's in NFPA. Ang iba kasi gumagamit dito, magamit ka ng well-dulet na 1 in 1/2. O di T yun. Now, anong ibig sabihin nito? Pagpapunta ka doon, go back. Alin ang kukonsider mong T? Ito yung ting pinanggalingan mo ang kukonsider mong T. Pagpapunta naman doon, anong gagamitin natin? Ito yung pinanggalingan niyan T. Ayan yung ibig sabihin niya. Next, when adding fittings to the hydraulic calculations, you should be aware that certain fittings do not add enough turbulence. In 234471 of NFPA 13, there are 10 items that include direction on which fittings to include. It also gives guidance on which fitting do not need to be included. Okay, may guidance tayo. Sabi ng 24471, pipe friction loss shall be calculated in accordance with the Hazen-Williams formula. By the way, 23447, NFPA 13, walang ibang kwan yan. Now, as follows, sabi dito, para sa lahat ng fittings dyan, friction loss dyan, include pipe, fittings, and devices such as bulbs, mid-flow switches in pipes 2-inch or less in the size, and strainers, and calculate elevation changes that affect the sprinkler discharge. So lahat ng fittings and pipes, flow switches, tie-in drain, piping. Halimbawa, may drain ka, hindi yun nakasala. Wag mo na, may T ka sa drain mo. Nag-attach ka ng drain, may T doon, hindi kasama yung drain, yung papuntang drain. Bakit? Papuntang, pag ginamit mo kasi yun, lagi naman nakasarado yun during sprinkler operation, lagi naman nakasarado yun. Gagamitin mo lang yun kung magdi-drain ka. So, walang gamit ang sprinkler doon. Papunta yun sa atmosphere, sa ground papuntang ground pala. So, hindi yung kailangang isali sa hydraulic or a T or a cross where flow direction change occurs based on the equivalent pipelet of the piping segment in which the fitting is included. For the T at the top of the riser nipple shall be included in the branch line. Ulitin ko. The T at the top of the riser nipple shall be included in the branch line. The T at the base of the riser nipple shall be included in the riser nipple. And the T at or cross at the cross main to feed main shall be included in the cross main. So yun ang pagkakakuha niya. Kung nakaka-touch siya sa cross main mo siya i-consider. Next, do not include fittings loss for a straight roof flow in a T or cross. Ibig sabihin, coupling, straight coupling. Gumamit ka na straight coupling, pinagdugtong mo ang dalawang D1. Wala yun. Huwag mong gamitin. Walang friction loss doon. Uli, sabi nga, unless it is a CPVC pipe kasi gawa ng contact cement. Nakaroon ako yun. Number 6, calculate the loss of reducing elbows based on the equivalent fit value of the smallest outlet. Yan yung sinasabi. Mayroong reducing elbow. 1 by 1/2. 2 by 1/2. 2 by 1. Yung 1, elbow ng 1 inch ang gagamitin mo. Doon sa equivalent let. Wag yung 1 malaki. Use the equivalent fit value for the standard elbow on any abrupt 90-degree turn such as the screw type pattern. Halimbawa, meron kang screw type na fittings. Gagamit ka doon na, yan yung pagkakaiba ngayon. Sorry guys. Ito. 90 degrees standard elbow and 90 degrees long turn elbow. Itong 45, madaling intindihan yan. Saan mo gagamitin ang 90 degrees standard elbow at saka 90 degrees long turn elbow? Dito na yan. Ito na yan. Binibigay na explanation. Ito yan. Use the equivalent fit of standard elbow on any abrupt 90 degree turn such as screw type. Kung magagamit ka ng screw type na elbow. Use the equivalent fit value for the long turn elbow or any sweeping 90-degree turn such as flange, welded, or mechanical joint elbow type. Kung gagamit ka ng mechanical elbow o mechanical T, flange, elbow, welded elbow, ang gagamitin mo yung yung long turn elbow, hindi yung standard elbow. Okay. Friction loss shall be excluded for the fitting directly connected to the spring. Shall be excluded. Ibig sabihin, may fittings ito, hindi nakasama. Do not need to be considered. Losses through a pressure reducing valve or PRV shall be included based on the normal inlet pressure condition. Pressure loss data from the manufacturer's literature shall be used. So yung mga PRB, since nawala yun sa equivalent length of pipe natin na table, kukuha ka ngayon sa literature ng manufacturer. Okay. Next. For the branch line shown, we need to include the teeth at the top of the riser nipple. O, di ba? Ganito ang nangyayari sa atin. O. Papunta dito, kasi 1 inch yan, gagamitin mo yung 1 inch. Pag papunta doon, gagamitin mo 1 in 1/4. Yan ang kaibahan ng kinato, ng kanto na to. Kasi magkaiba ang size. Oh. The water will turn going into the 1 inch outrigger and the water will also turn into the 1 in 1/4 inch. That's why 1 in 1/4 sa kabila, 1 inch sa kabila. We will account for a T and H cross pipe segments in our path. We will also include a T in the pipe segment that describes the riser nipple as shown by figure 2.36. O yan. Yes. Ito, tingnan nyo to sa babang to. A T-turn will need to be accounted for at the bottom of the riser nipple and should be included on the pipe that is the riser nipple. Ibig sabihin, ito, pang riser nipple to. Kung ano yung tinanaan dyan, diba 3 ito, 3 by 1 in 1/2. So, magamitin natin dyan, T equal na 1 in 1/2 para sa riser nipple. Sa riser nipple. Alright. So, 7.2. Determine the minimum requirements starting pressure for your end outlet. Okay. Dito na tayo sa table. Kanina, nailagay na natin to. Ito, alam na natin to. 7 plus 5 is 12. C is 120. The pressure is 11.4. Bakit 11.4? Ito yung formula. Yung 18.9, sa notes, sa remarks, ito ilalagay natin. 18.9, nandun. Q is equals to area of sprinkler operations times density. Itong formulang ito, minsan mo lang itong gagamitin sa mga dulo ng sprinkler head lang. Yung susunod na sprinkler head, hindi yan ang formula. Hindi ito ang formula sa susunod na sprinkler head. Sa dulo lang. So, what is the pressure? Q over K squared. 18.9 over the K factor, 5.6. 11.4, lagay mo na doon. Total pressure. Wala ka pa ibang pressure sa yung unang-una mong ikakalculate pa lang, kaya lagay mo sa total. Ito elevation. Ito friction loss. Okay, so punta na natin. Sunod. Verify that Q, K, and P are valid each time a new pipe segment is started. Okay, next. Okay, next. Narito pa rin tayo sa dati. 10.5. Ang tanong dito sa 7.5, ano ba sa rise 4 to 1, 4 to RN1, kung dito ay 18.9, ano ang flow dito sa RN1? Sa RN1. O diba, kung ano ang flow, dito yan, para madali natin maintindihan. Kung dito ay 18.9, ang kailangan dito, ano ang flow ngayon dito sa RN1? Di 18.9 din. Kasi alam mo, maliit sa 18.9, ang paano makarating ng 18.9? 18, iisa lang. Magkakaroon ka lang ng friction loss sa travel mo yan na 7 feet. Friction loss. Pero still, ang flow mo dito dapat ay 18.9 papunta doon. Okay. So, that's the reason why ang Q mo sa RN1, itong RN1 mo, ito rin. 18.9. Kukopyahin mo lang siya. Next. 7.6. Determine if any fitting modifiers would apply to the pipe segment. Gumamit ba tayo ng hindi schedule 40? No. Gumamit ba tayo ng hindi schedule 20? No. Kapag ang sagot mo dyan, yes, di magkakaroon ka ngayon dyan ng mga equivalent length modifiers or magkakaroon ka ngayon ng mga correction. Yan yung kwan. Naggamit tayo ng GI pipe? Hindi. Pag gumamit tayo ng pipe, yes. Magkakaroon tayo ng iba. Magkakaroon tayo ng mga modifiers. Tayo ng mga formula. Ito yung mga modifier, equivalent length. Halimbawa, GI pipe sa taas. Sabi natin, wala lang GI pipe. Sabi natin, BI pipe, ibang schedule lang. Schedule 30, schedule 80. So, actual inside diameter, no, schedule 30 or schedule 40 over the inside diameter ng schedule 40, ito na yung factor mo, multiply mo. Doon, saan mo multiply yung factor na to? Doon sa equivalent T, o equivalent friction head loss sa mga sa table na head loss. Kung 1 inch siya, kung 2 inch, i-multiply mo lang para dumagdag. Ito naman sa C factor para sa Hissing-Williams. Pag gumamit ka ng hindi 120, C factor pag hindi ka gumamit ng C factor pag ang ginamit mo other than C factor of 120, at gumamit ka ng iba, gumamit ka ng 100, i-multiply mo siya ng 0.713. Pag 140, i-equal mo siya ng 1 multiply mo ng 1 at saan mo gagamitin yung modifier na yan? Sa C factor. Pag pumasok ka ngayon sa Hissing-Williams equation, may C factor dun eh. Doon mo siya papasok, yung modifier, yung multiplier na yan. Okay. Example, para hindi tayo nalilito. Example ng modifiers.
Iiwasan ko kasi na pagka kung hindi na yung mga maliliit na problema, pinapaayos ko kasi mamaya lumaki yun, di ba? Tapos na yung warranty. Yung kay Charlie sinasabi. Kailangan hanggat kayang paayos mo.
Pakunin na natin siguro.
Pero kung sa makina at makina, wala siyang problema talaga. Kasi, pwede ko, alam mo naman, wag dinadrive.
Christian, paki-silent muna. Ikaw ba yung nandyan?
Sorry po.
Okay, sige. Okay, let's go. Let's proceed, guys. Sample sa modifier. Before I proceed, kasi baka malito kayo. Baka maiwan ko kasi iba na yung sample natin eh. Wala modifier yung sample. Halimbawa may modifier tayo. May ibang factor tayo ginamit. May ibang bakal. May ibang C factors. Ito yung sample. Diba? Ito yung formula natin. Example, gumamit tayo ng schedule 40, 10 feet. Ang C factor mo ay 100. 135 GPM ang flowing. So, ipapasok mo na dyan, yung 100 na to, yung 100 na to, ipasok mo na ngayon dyan, C factor mo. So, 2.7. So, yung 135 ngayon, dyan pa rin naman. 4.52, formula yan eh. 2.067 kasi 2 inch. 2.7. Since gumamit ka ng 100, ano sinasabi? Pag gumamit ka ng 100, i-multiply mo daw ng 0.713. Multiply mo siya ng 0.713. Pag multiply mo siya ng 0.713, yung 1.9 PSI, liliit na. Ganon yan. Yan ang effect ng iyong ibang materials sa Hissing-Williams. Okay. 7.7. Determine the friction loss per foot. Ito na yung formula natin sa friction loss per foot. Kapag ilagay mo sa calculator, ito yun. Ngayon, wag mo muna i-multiply nito. Wag na muna. Ito na muna. Ito na muna. Ito na muna. Kasi friction loss per foot pa ang kailangan mo eh. Friction loss per foot. Pag multiply mo ng L, the friction loss na lang siya. PSI na siya. Okay. Next. Since na mayroon tayong kanina 18.9, yan, 18.9 GPM, ilan bang friction loss per foot mo? Yan na yan, ipasok mo na yan dyan. Nandiyan na. Tapos, ano ngayon? Anong mangyayari dyan? Sunod na table mo, ito na. This times this, total, equals this. Di mayroon ka na. Bakit elevation? Wala. Wala kang elevation kasi di ba 19 feet. 19 feet. O di wala kang elevation loss. Now, kapag ang elevation, kukumpitin mo ang elevation, kapag ang elevation ay paakyat, positive. Kapag pabagsak, pababa, negative yun. Kasi bakit ganun? Kasi pag pababa, ay di magaan ngayon sa, kapag ang pipe pababa, ang flow ay pababa, magaan ngayon sa pump. Pababa na gravity na. Pag ang flow ay paakyat ng paakyat, mabigat sa pump. So, positive elevation loss. Friction loss due to elevation. So, ganun. So, since nawala tayong friction loss due to elevation, kaya zero yan. Zero. Oh, uli. This friction loss per foot times 12 is 1.4. O, nandiyan yan. Okay. Next, 7.9. Determine any elevation loss or gain. Wala tayong loss or gain. Wala. Zero. Zero. Because of this. Next. Total required pressure to create a total flow. 11.4 plus 1.4, 12.8. Meron ka ng 12.8. Doon yan sa third attachment path. Natapos mo na yung third. Ano ngayon kung meron akong 12.8? Anong gagawin ko? O di ba? Kailangan mo ang 12, yung attachment path na yan. Bakit kailangan mo dito ng K equivalent K factor? Yan dito. Kailangan mo ng equivalent K factor dyan. Kasi yung iba, yung isa, tubig papunta doon. Ano ang kailangan? Bakit kailangan mo ng equivalent K factor? Magkaiba Yung isang tubig, yung ilang tubig going to 1, 2, 3. Yung volume ng tubig papuntang 4. So meron ka sa gitna. Correction factor ang tawag do, correction K factor or equivalent.
Okay, good afternoon everyone. So I think kaning presentation din nato Muhammad no. So kung asa ra tama na nga atong presentation ato ra tama na atong quiz. Anyway, the presentation will be uploaded in the Google Classroom di ba, for your reference. So pero dili lang nila ko i-upload once dili ta mahuman sa quiz no. Kaysa akong gingon dapat naminaw mo, nakasabot mo sa inyong gipaminaw. Okay? Madungog ra ba ko, class?
Yes, sir.
So i-end na to karon kay nami meeting no, urgent nga meeting. So I think ma-late kung samot kung ato pang ihuwaton nga mo 3:30. Okay, class. So sa attendance lang no, i-double check na to attendance. Kasi may naadiri nga wala ma-check sa attendance kani ha. Adansa si Balasabas, ano sila? Bulakoy. Balik ka. Adansa, wala. Balasabas.
Sir.
Si Balbido. Bulakoy.
Present, sir.
Si Castillon. Si Doldolia. Si Guno. Si Hibaya. Hibaya. So kindly ko na lang no, turn on your microphone para madali ta. Di na ako mag-open sa screen. Humawid. Si Humawid, I think na si Humawid ganihan. Laurito.
Present, sir.
Ligaspe.